morning, everybody, and welcome along to our Sustainable Space event from the team here at the Rediscovery Centre with the help from our friends over at Science Foundation Ireland. You're very welcome on board for our event here today. We've got lots and lots of stuff going on throughout the day, stuff for people of all ages, from the littlies in the morning to the biggies in the afternoon and into the early evening. You can check out the entire running order for the event in the description box just down below. So we're being joined by people from Armagh Observatory and Planetarium, Blackrock Castle Observatory, Dunsink Observatory, ILOFAR, and Secure World Foundation. So we're being joined by friends all across Ireland and even some a little bit further afield. Very importantly, we are live. So make sure you tell us in the chat that you're here, say hello, let us know where you're watching from, maybe share some of your favorite space facts, and we'll read out a few of them as the day goes on. Ask as many questions as you like. Your first question may be, who is this crazy lady talking to me on the screen? My name is Ali. I'm part of the education team here at the Rediscovery Centre, and I'll be your host for today's events. So if you are here in the chat, make sure you give us a wave, say hello, let us know who you are, where you're tuning in from, and why you are so interested in the whole world of space. So without further ado, we are going to get cracking, I think. Just make sure that when you're writing in the chat that we're all nice and polite and keeping it on topic. We do have some bouncers behind the scenes, some security guards, who will be removing anyone who is rude in the chat or saying things they're not supposed to be saying. So keep it clean and keep it nice in the chat as much as you possibly can. And we're going to have an absolutely amazing day. So the team from the Rediscovery Centre here are going to kick things off first. So on that note, I would like to introduce our Head of Education, Sarah Clear, who's going to join us on the call and talk to us a little bit about the wonderful world of space. Hey, Sarah, how are you?
Hi, Ali. How are you doing? I'm so excited about today's space event. How are you?
I know, it's going to be absolutely fast. I'm really excited, but I know you're extra excited because you are a self-proclaimed space nerd. If I'm okay in saying.
I have to confess, my name is Sarah and I'm a space nerd and delighted to be so.
Good. So, Sarah, before we kick off, we do a few people in the chat already saying hello. So we're going to say a big shout out to Paddy, Sheila, and Charlie, who are all in the chat already. Good morning, everybody. Up bright and early to learn a little bit about the wonderful world of space. So, Sarah, why are you so interested in the whole universe of space, I guess we'll call it?
Well, the reason I'm interested is there's so many cool things to learn about space, and it brings together so many aspects of science, engineering, technology, maths, all those kind of things, which I also love.
Yeah, definitely.
It's just really interesting, and there's lots of amazing things to discover out there. And I'm actually really interested in the environment as well. So I love learning how we can protect our environment more as we learn about space. And I'm very excited about seeing all our speakers today.
Class, yeah, and that's exactly what today's event obviously is all about. We could have just done your run-of-the-mill space event, but as you said, we are very passionate about our planet and about how we can explore our universe while also being a little bit kinder to our own planet. So that's what the Sustainable Space event is all about. So you'll see that theme kind of running through all of our speakers that we have coming up today. And so what we want people to do is we want people to get as involved as possible with the day. So as we said, saying hello in the chat, I'm going to say hello to Sarah, who has also popped into the chat. So saying hello to everybody, letting us know if you have any questions for any of our speakers, pop them into our chat. If you are watching the show today, make sure you take pictures, you take selfies, pop them up on social media and tag us at the Rediscovery Centre. We're on every single form of social media there is. So make sure that you let us know that you're here, share with your friends, and we're going to get as many people tuning in today as possible. So Sarah, you're going to kick things off today for us.
Mm-hmm.
So do you want to tell everyone a little bit about what you're going to be doing with us first thing this morning?
So what I'm going to be doing is I'm going to be talking about space in terms of a bit about the universe, a little bit about planets and galaxies, and then we're hopefully going to have loads of questions from you guys watching at home, because I know everyone loves space and everyone has loads of cool questions. So we're going to try and answer as many as we can. And I'm going to let you guys know some very cool facts about space, some of my favorite facts as well. So hopefully everyone's really excited, ready to go. And I know later on, Ali, as well, you're actually going to be showing us a couple of things that people can do at home, including rockets.
Exactly, yeah. So it's not just all about sitting and listening and learning today, which is obviously all very exciting, but we want you to get involved and get hands on as well. So after Sarah teaches us a few cool facts about space, we're going to see some videos that we recorded earlier of how you can make your own rockets and a few other challenges as well. So without further ado, Sarah, do you want to kick things off for us?
Absolutely. So, hi everyone. I'm Sarah Clear with the Rediscovery Centre, and I'm going to be doing this workshop with you guys all about sensational space, because that's definitely what I think about when I hear of space. So, I'm going to share a presentation with some very, very cool images for you guys as well. So, let's get cracking. And Ali, if there's any questions coming in from people, feel free to stop me and I can answer those questions as well.
Don't you worry, I'll be lurking in the background at all times.
Sounds perfect. So we're so delighted today that our Sustainable Space event is actually very kindly funded by Science Foundation Ireland under our STEM and Sustainability project. And we have lots of amazingly cool things going on, like workshops for schools, teacher CPD, and lots of really cool events like this as well. So we're delighted. And a huge thank you to Science Foundation Ireland. Bye, guys. So, welcome to the universe. This is a real picture of our universe that was taken by the Hubble telescope, which is a massive telescope that's out in space right now. And this is a picture that the Hubble telescope took, and what it actually shows is absolutely amazing. So you can see some stars there, but you can also see some blurry kind of spots of light. And can anyone guess what those might be? They are galaxies. So we're actually looking at an image of hundreds and hundreds of galaxies. Now, a galaxy is a collection of billions and billions of stars. And lots of them are different shapes, different sizes. Some of them are really far away from us, and some of them are relatively close as well. So this is an incredible image showing just what's out there in our universe. Now, a question I often get asked is, how old is the universe? Well, the universe is 13.8 billion years old. That's 13 followed by 9 zeros. So it's incredibly, incredibly old. And scientists have done lots and lots of study as to how old the universe is. And they use science and actually maths as well to help them figure out how old it is. So incredible work goes on in the background. So we learn all these space facts. Another question I get asked is, what does the universe contain? Well, the universe contains planets, stars, galaxies, black holes. It contains our planet and us. The universe contains absolutely everything that exists. There is no outside of our universe. Another question, and this one is one that has been puzzling scientists for an incredibly long time. How big is our universe? The answer is we actually don't know. The universe might go on forever, or it could just be immensely, immensely huge. And a lot of scientists think that if you were in a spacecraft and if you traveled in a straight line and kept going and going and going, they think eventually you might actually come back to the same spot, which is a really, really weird thing to think about. But if you imagine, just say on our planet, if you got into an aeroplane and traveled in a straight line, eventually you come back to the same spot again. And that's because we're in 3 dimensions, but our universe is in as many as 11 dimensions, which is really, really hard to picture. Kind of blows your mind, doesn't it, Ali? But they think
Yeah,
that eventually
I can barely
you
get my
might
head
come
around
back to
three
the
dimensions.
same point.
I can barely get my head around 3 dimensions or 2
I
dimensions,
know.
let alone anymore. Like, I don't think my brain's able for that at all.
I know. And actually, that's a lot of scientists are actually looking into answers like that as well. So there's amazing stuff about the universe. So the universe, 13.8 billion years old. No idea, no one has any idea how big it is. and it contains absolutely everything that exists. Amazing to think about. And you can find really cool images from telescopes like the Hubble telescope. You can find them on the European Space Agency website and the NASA website as well. So there's really cool images out there. So you can do a little bit more exploring into it and research into it at home. So now we're going to talk a little bit about galaxies. So as I said, a galaxy is a collection of billions and billions of stars. And in the center of galaxies are super massive black holes. Now, we don't need to freak out too much. These supermassive black holes aren't going to suck us in anytime soon. Don't need to think about it. But what these supermassive black holes in the center of galaxies do is their immense gravity keeps the whole galaxy together and stops the stars from flying off in different directions. Now, the reason that galaxies are brighter in the center is because there's more stars. So the closer you are to the center of a galaxy, the more stars and the brighter it is. So there's lots of different types of galaxies and lots of them are different kind of shapes. You get ones that look like kind of like a cloud, and those ones are really young galaxies that are still forming. You get ones that are long, kind of straight line kind of shapes. And you also get spiral galaxies like our own galaxy, the Milky Way. So this is a spiral galaxy here, the Milky Way. And it's kind of a fairly average sized galaxy, but it's still incredibly, incredibly big. It takes light, and light is the fastest thing in the whole universe. It takes light 500,000 years to travel from one side of our galaxy to the other. And our sun is nowhere near the center of the galaxy. We're actually way out on one of the spiral arms of the galaxy as well. Amazing, amazing, amazing to think about. But if we were closer to the center of the galaxy, it would actually be quite bright even during the night because there'd be so many stars around us. So that's just a little bit on galaxies and Milky Way and the Milky Way. So if you've got any questions coming through, Ellie, just feel free to stop me at any stage at all.
I want to ask Sarah, which came first, the galaxy and Milky Way, the space things, or the galaxy and Milky Way, the chocolate bar? That's what I want to know.
Great question. Thank you, Ali. Well, it was actually called the Milky Way first. So it was the galaxy was actually called the Milky Way first. And you'll know this if you've ever been out somewhere quite dark um, at night time, and if you look up at the night sky, it looks like a trail or a line of lightness across the sky. So that's why it's called the Milky Way. And our ancestors used to have lots of cool stories about the origin of it until we figured out what it actually was. So it's actually our galaxy as well. And the Milky Way bar was named after it.
And the Mars bar, I assume, too. There's a lot of chocolate bars named after space things, is what I'm kind of realizing here.
Absolutely. So this is an image of the Milky Way from Earth. It's absolutely incredible to see. But if you live in a city, because of light pollution, all the street lights, you can't really see this. So you need to go to an area that's dark and doesn't have many street lights. And there's lots of areas around Ireland that can be great to see this as well. So places like Mayo, Donegal, and Kerry as well. So the next time you're on holidays with your mums and dads, all you people at home, go outside at night time with your mums and dads on a clear night, and you might see something that looks like this. And we're actually looking at our own galaxy, the Milky Way as well. It's incredible, incredible to see it. And obviously, the brighter area here is the center of our galaxy, the Milky Way, because there's more stars. Now, what scientists do sometimes as well is they can actually zoom into these different parts of the sky and they can actually see all the different stars that are there as well. So they can see things like just how many stars are in a particular patch of this. And not all stars are the same colors. Some stars are a kind of blue color, some are yellow color like our own star, the sun, and some are even really red color as well. And the type of light it gives out tells you what type of star it is too. So again, you can discover loads about that as well. So very, very exciting to be able to see our galaxy from Earth as well.
Sarah, I'm going to interrupt you there for a second, just on the topic of stars. I've got a question coming in from Claire, who is asking how shooting stars work.
Oh, that's a super question. So a shooting star isn't actually a star at all. It's actually a meteor. So it's either a small or slightly bigger piece of rock that comes in towards our atmosphere. And as it hits our atmosphere and it's coming in so quickly, what actually happens is the atmosphere actually slows down the meteor and it heats up so fast through friction that it actually emits light or lets out light. So that's what we see streaking across the night sky. And most of the meteors that we actually see, or the shooting stars that we see, are very, very small and they burn up way before they actually hit into the earth. So
So
it's only raining.
our atmosphere is doing a good job of keeping us safe, is what you're saying.
Absolutely, and it's so important for a planet to have an atmosphere because if it doesn't, there's nothing slowing down those meteors, and they often hit into the Earth as well, which is really not great.
No, not great. So, guys, on that note, do please keep the questions coming in because clearly Sarah knows a huge amount about space. So, let's try and get as many questions answered as we possibly can. So, Sarah, we'll leave you back to it again.
Excellent, thank you so much, Ali. So another thing that you can see in the night sky is we'll often see patterns of stars up in the night sky as well, like the one on the right hand side here. So you've probably looked up at the night sky and seen three stars in a row, and you've probably been told that that's Orion's belt. So, what humans have done is over the centuries, as we're looking up at the night sky, we kind of make patterns from the stars that are up there all the time. And these are what we call constellations. And humans have been creating stories about these constellations. So, this one here, so the three in the center are Orion's belt, but they're actually part of a bigger constellation called Orion the Hunter. So, you can see then on the left hand side, if you kind of imagine that they're all joined up. It looks a little bit like a man with a bow and arrows as well, and that's why it's called Orion the Hunter. And there's a huge amount of constellations actually out there in the night sky. And if you're really interested in learning more about the constellations, you can download lots of different free apps on your phone, like Sky Tracker and things like that, where if you point your phone up at the night sky, it'll actually show you the different constellations, and they're amazing, amazing, amazing things to see as well. So now we're going to talk a little bit about our solar system. So what is actually in our solar system? So we've got the sun at the center of our solar system, and the sun is so huge that 99% of all the stuff or matter in our solar system has gone into the making of the sun. It is absolutely huge. So the solar system also includes all the different planets as well. But not only that, it also includes the moons, asteroids, and meteoroids. It contains comets and dwarf planets. So a dwarf planet is a body that isn't big enough to be classified as a proper planet. It's smaller, and we actually have 5 dwarf planets in our solar system, including Pluto, that we all know, and Ceres, and Eris, and Makey. But our solar system extends out way, way, way beyond Pluto. It actually includes the Kuiper Belt objects. So these are lumps of ice and rock that are out really, really far beyond the orbit of Pluto and Eris as well. So there's lots of amazing things to discover about our solar system. Now, our solar system is kind of made up of the sun at the center, and then we have 4 rocky planets that are mainly made of rock and bits of metal and other elements as well. So we've got Mercury, that's closest to the sun. We've got Venus, the Earth, and Mars. And then just after the orbit of Mars, between Mars and Jupiter, we have the asteroid belt. Then we get to the gas giants. So the gas giants are obviously huge planets, but instead of being made of kind of rock and metal and things like that, they're mostly made of different types of gases. Now, the biggest one and the closest to us is the planet Jupiter. Then we have Saturn, Uranus, and Neptune. So that is the 8 planets in our solar system, and each one is really different. And there's incredible stuff to learn about each of these different planets in our solar system. So now we're going to learn a little bit more about them. And if anyone has any cool space facts about the planets that they know, pop them into the chat. We'd be delighted to read them out because we love hearing more about what you guys know too. So first of all, we're going to talk about our sun. So the sun is absolutely massive. It is so huge that 1 million Earths would fit inside it. So this picture was taken not with a normal camera that uses light, because obviously we just get a big blur of white light if we try to take a photograph. This one was taken using a thermal camera that actually takes a picture of the heat. So what you can see here, the red and orange parts are slightly cooler than the really, really white parts of this. But the average temperature at the surface of the sun is 5,500 degrees. So just imagine a kettle boiling at home. That's only 100 degrees. Now that could burn us a lot. The sun, 5,500 degrees. And it's a big swirling ball of mainly hydrogen and helium. And it does orbit, so it does turn on its axis as well. And what you get are all these little patches where it's even brighter and hotter because it's the gases kind of bubbling up to the surface as well. And as it bubbles up, it lets out some of these solar flares too. So there's lots of incredible things that we're learning about the sun. And scientists are actually sending satellites closer to the sun to learn more about it all the time as well. So really, really cool stuff to learn about our sun. And as I said, the sun is so big that its gravity actually keeps the whole solar system together. It keeps all the planets orbiting around it. And then even all the comets as well, even though some of them are incredibly far away, because the sun's so big, its immense gravity influences everything within our solar system.
Sarah, we've got a few cool questions that are coming in that kind of relate to our sun a little bit. So
Great.
Julie would like to know, how does the sun keep hot? So what exactly is burning in our sun?
That is absolutely fantastic question. Well done. So the sun isn't really on fire like we know fire is kind of in our fire at home in our living room. What's actually happening is all of these gases, so the hydrogen and helium, is actually fusing or coming together. All those atoms are coming together and they're actually letting off huge amounts of radiation. And that's really what's happening inside our sun as well. Nuclear fusion is what it's called. And that's actually what's powering our sun.
That's some very big science words there with nuclear fusion and all these things. But that makes sense as to why the sun can burn our skin, because we're talking about radiation as opposed to things being really on fire, I guess. Another question has come in from Paddy. So Paddy would like to know, obviously the sun is so bright, the sun makes there be daytime and nighttime on planet Earth. Is there a nighttime in space?
That is a really, really interesting question. So if you were really far away from a star, it would be nighttime all the time because all you'd see are stars that are really far away. So small little points of light all around you. But if you're close to another star, obviously that would be providing with daytime. So anytime our planet is facing the sun, it's daytime, but it's facing away from the sun, it's nighttime. And because our planet rotates, so turns on its axis, we get day and night depending on whether we're facing the sun or turned around to the other side. And it's exactly the same with other stars as well. So any planet around them that's orbiting around them and turning will have day and night too. Super question. Thanks,
So it
Patty.
all just depends on how close you are to your closest star. Basically, it's going to determine
Absolutely.
how much daytime you have, how much nighttime you have, if you're all daytime or all nighttime.
That's it. Absolutely brilliant.
Brilliant.
And
Thanks very
our
much, Sarah.
sun is 4.5 billion years old. It has been shining for that long, so 4.5 billion years, and it will continue to shine for another 5 billion years. So, we don't have to worry about our sun running out of fuel or anything like that, thankfully. Any other questions coming in there, Ali?
I think we're good to go. So you're going to have to give some people some more thinking fuel. So we'll run through a few more slides. But everybody, do please keep the questions coming in. They're absolutely fantastic. So we'll get to as many questions as we can. But Sarah, we'll let you keep talking about our beautiful solar system from here.
Perfect. So next we're going to talk about the closest planet to the sun, which is the planet Mercury. And as you look at this image, it looks a little bit like our own moon. So it's made of mainly rock, but some other metals and elements in it as well. Now, Mercury is quite small. There's actually moons within our solar system that are bigger than planet Mercury. Mercury has no moons itself, but because it's small and because it's close to the sun, it actually has no atmosphere. It's not able to hang onto a protective layer of gases all around it. So when any rocks from space or meteors from space come towards the planet, what happens is they crash straight into it. There's no protective layer of gases around it to protect the planet. So as these meteors crash into the planet, they create these amazing craters all over the planet as well. Now, Mercury is so close to the sun that it only takes 88 Earth days for it to orbit or travel the whole way around the sun. If you were standing on the surface of Mercury and you were facing the sun, so in daytime, the temperature is 430 degrees. But as you turn around and face away from the sun, so for nighttime, it goes down to minus 180. So really extreme temperatures on the planet Mercury as well. Absolutely fascinating planet as well. So the next planet so here is a picture of a meteor crater on Earth. So we see those craters that are happening on Mercury. But sometimes, even though we've got this layer of protective gases around us on planet Earth as well, what actually happens is sometimes if a meteor is big enough and traveling fast enough, it can actually come through our atmosphere and crash into the surface of our own planet as well. Now, it doesn't happen that often, so you don't need to worry about it, but this is what it looks like when a meteor hits into the Earth, and it's very similar to what happens on Mercury as well. So this crater is 3 kilometers across, 1 kilometer deep, and what you can see in the center is a small little town. And this was created by a meteor about the size of a house. So a lot of crater for quite a small meteorite. Amazing to think about as well. And a lot of the meteors actually on Mercury are even bigger than that one as well. So the next planet we're going to talk about is Venus. Now, this planet is very different to Mercury. Again, it's a rocky planet, so made mainly of rock, metals, and other elements as well. But instead of having no atmosphere or no gases around it, this one has a huge amount of gases around it. It has so many gases and atmosphere that if you were to land on the surface of Venus, you'd actually be squashed down under the weight of all those gases around it as well. And those gases actually keep the planet really hot as well. It's the hottest place in our it's the hottest planet in our solar system, and the temperature there is 462 degrees. And also, instead of raining water, it rains sulfuric acid on Venus. because there's acid in the clouds, and when it rains acid. So not a very nice place to visit as well. So scientists have sent robots down to the surface of Venus because no human had ever seen it until we sent a robot there. So we send robots there, and then they can take pictures and send them back to Earth. So they send the pictures kind of the same way like a phone sends it. So the information flies through the air. But the robots only last about 40 minutes on Venus because of the weight of all of that pressure from the atmosphere and also all the acid. Not a nice place to visit, but an amazing place to learn more about as well. And here is a picture actually taken on the surface of Venus. Absolutely amazing to see. And the reason that the air is yellow is because of the acid in the air. Really, really weird planet. So the next planet we're going to have a look at is planet Earth. And we know loads about this planet. I'm sure you guys do too. But Earth is often called the blue planet. And the reason is because it has a huge amount of water. It is the only place in the whole solar system that has liquid water at the surface. It's the only place in the solar system where we can breathe easy because it has the right type of air containing oxygen that we can breathe. And if you see as well, if you look at this picture, you'll also see green. Now, what does the green on the planet mean? Doesn't mean land, it means plants. So it's the only place in the solar system as well that plants can actually grow. We've got the right type of soil, bacteria can grow, plants can grow, and therefore animals and us can survive as well. And all this white stuff that we can see is clouds, and very luckily for us, on Earth it rains water, not acid. But we actually know less about our oceans than we do about lots of other things in space, including our moon. 12 people have stood on our moon. Only 4 people have been to the deepest part of our ocean. So we've explored more about the moon than we have about our own oceans. Very, very weird to think about that one, isn't it? And obviously planet Earth just has one moon, the moon. And the moon is about a quarter of the size of our planet. And even though it's the closest object to us, it's still incredibly, incredibly far away. So this is a really cool image actually showing the distance between the Earth and all the way over here, the moon. They're so far away that you could fit every single planet in the solar system in the space between the Earth and the moon. So even though it's close, everything in space is really, really far away, including our own moon as well.
Sarah, we've got a few questions coming in here. Sorry, Sarah, we've got a few questions coming in here. I think some people are a little bit concerned about the meteorites striking planet Earth. So we have 2 questions that have just come in about this. So one question is asking, what attracts the asteroids towards planet Earth? And the second question is, could it happen that one could strike us completely unexpectedly, or do we have some kind of warning that they might be kind of swooping in at us?
Excellent questions as well. Brilliant. Okay, so meteors and asteroids and things like that, all these kind of lumps of rock are all in orbit around the sun, but sometimes they go slightly off course, usually due to gravity from another planet, usually Jupiter and stuff has a big influence. And sometimes they come hurtling towards a planet. Now, the reason they actually come in close is because of the planet's gravity. But we are so lucky on planet Earth that we have this layer of protective gases around our planet. So most of them actually burn up in our atmosphere and we don't need to worry about them. It's only extremely, extremely, extremely rare that asteroids actually hit into our planet. So we don't need to worry about it. Plus the fact that on Earth, we've got lots and lots and lots of scientists who are actually keeping an eye on all these objects that are orbiting around space, and we will know definitely if any are coming in towards us, but it's extremely unlikely. Space is so incredibly huge, and relatively speaking, our planet is very, very small.
Mhm.
So the chances are that all of these asteroids and meteors and things like that just pass us by and we don't need to worry about it, or they burn up in our atmosphere. So nothing to worry about, guys.
Brilliant. So we're always keeping an eye on things. Plus, we've got
Hmm.
our atmosphere as a backup just in case.
Absolutely, yeah. And
Brilliant.
that's really good
Cool.
to do. And I know lots of people do get concerned about that, but no need to worry about it.
Brilliant. Okay, Sarah, we'll let you go back to the planet Mars.
So the planet Mars, the Mars is called the red planet. Now the reason it's red is because there's lots of iron in the rocks. And the iron is basically rusted, causing it to be a red color. So that's basically why Mars is red. It's a rusty planet. Very, very weird as well. So Mars is smaller than planet Earth. So it wasn't able to keep onto its gases as or its atmosphere as well as the Earth can. So it has a much less dense, so a much lighter kind of atmosphere. So we couldn't actually breathe on planet Mars because the atmosphere is too light or not dense enough. But Mars as well is really cool because it used to be a volcanic planet as well. And the biggest volcano in our solar system is actually on planet Mars. It's called Olympus Mons and it's 21 kilometers high and 600 kilometers wide. And now that we have sent loads and loads of robots to this planet, we know lots more about it as well. And we know that Mars used to have some water on it, but now there's very, very little water, and all of that is locked away as kind of ice in little pockets and at the poles as well of this planet. So Mars has two moons called Deimos and Phobos. And also, it has these huge dust storms. So it's really windy on the planet, and it's got the biggest dust storms in the whole solar system as well. Mars really is an absolutely incredible planet. And here's some pictures that were sent back by rovers on Mars. So the one on the right hand side is a selfie taken by a Mars rover as well. And you can see it looks really dusty and rocky on the planet. The one on the left hand side actually shows some volcanic rock. And that's how we know that there used to be volcanoes on Mars. So then we're going to move to the planet Jupiter. So the planet Jupiter is the largest planet in the solar system. It's so large that 1,300 Earths would fit inside the planet. Absolutely huge. Now you couldn't stand on Mars or on Jupiter because it's a gas giant. It's made up of a swirling ball of gases. So if you did try, what would happen is you just fall through the atmosphere and end up in the center of the planet. But you wouldn't be able to breathe the air, and the weight of all the gases above you would actually squish you down flat. So you definitely don't want to visit into the center of Jupiter as well. So what we see, all these bands here, are actually the winds swirling around all these different types of gases as well. So it's basically an enormous ball of swirling gases. And the winds travel at different speeds all around the planet, causing this big kind of swirling around here, including at the center, this great red spot, which is a huge storm that has been raging for 350 years. The storm is so big that two Earths would fit inside that storm. Absolutely enormous. And Jupiter has 79 different moons, and some of its moons are actually bigger than the planet Mercury. Absolutely incredible, incredible, incredible to think about. So the next planet we're going to talk about is Saturn, and I have to say this is one of my favorite planets. Again, it's a gas giant, so it's made up of a swirling ball of gases, but it has these rings around it, which are made up of small little bits of ice. Now, sadly, you couldn't ice skate on the rings because they're all these small little bits aren't joined together. But getting up close to it, it's an absolutely incredible thing to see. And you can have a look and find images online of close-up pictures of the rings of Saturn as well. Absolutely amazing to see. The rings are really, really wide, but they're not that thick. They're between 1 and 3 kilometers thick in most parts as well. And what you find in the middle of those rings as well, you can actually find some moons in orbit with those rings. So there's not only moons around it in the middle of all those rings, there's actually moons in different parts. And in this image here, you can actually see two of the moons of Saturn. And Saturn has 62 different moons. But one of my favorite facts about the planet Saturn is if you could get into a spacecraft and start traveling into the atmosphere of Saturn, when you get down to about 100 kilometers into the planet, it starts to rain diamonds. And as you travel further and further and further into the planet, so when you're about 400 kilometers deep, those diamonds melt and it rains melted diamonds. Absolutely incredible, and one of my favorite space facts as well.
That is so weird, Sarah. So there's liquid diamonds inside.
Liquid diamonds.
So bizarre. Sarah,
Bizarre.
we're kind of running low on time here, so I just want to get through a few more questions if that's okay with
Yep.
you. So
Yep.
some people like to know if there are any live volcanoes on Mars or if they're all extinct like some of the ones here on planet Earth.
It's all totally extinct, unfortunately.
Okay.
Yeah, absolutely. So,
So
guys,
we
I'm
do.
just going to run really quickly through Uranus and Neptune, and then I'm going to answer even more questions from you guys, and we're going to show the videos as well.
Sounds
So,
great. Thanks, Sarah.
Uranus is the coldest place in our solar system. It's so far away from the sun, it takes 84 years to orbit around, and the temperature is minus 224 degrees Celsius. Really, really cold. And it also orbits at a tilt, so it nearly goes on its side, and that's what its orbit is. And the planet Neptune is the furthest planet from the sun. It has 13 moons, and it does have very, very faint rings around it as well. But what we always need to remember is that planet Earth is the only place that human beings can safely live. So we need to mind our planet because it's the only place we can grow food, have liquid water, and have the right type of air that we can breathe. So it's so, so, so important that we actually protect our planet too.
Totally, you're dead right, Sarah. Actually, that leads me nicely into one last question that I would like to ask you. Avril is asking if you could live on any planet other than planet Earth, which one would you choose and why?
I would
Tricky
say
one.
if I could, I probably would live in Mars, I think. It's just a very, very interesting planet, and there's so
Yeah.
much happening there as well. And I'd love to discover more about the planet's history too. So I'd say Mars.
True, that's a good one. That's a good one. Well, Sarah, if we were ever going to actually go to Mars or go and live on any of these planets, we would need a spaceship to get us there. So that leads us very nicely into our next video, which is a video that we recorded here at the Rediscovery Centre a few days ago, where I'm going to show you how to make a rocket from some materials that you might find lying around the house. So everybody sit back, relax, and enjoy the video. If you do make any of the things that we've talked about in our videos today, do make sure to take pictures, videos, tag us on social media because we'd love, love, love to see them. So without further ado, we will learn now how to make your very own rocket ship. Hello, everybody, and welcome along to our sustainable. Hello, everybody, and welcome welcome along to our Sustainable Space event. My name is Ali from the education team here at the Rediscovery Centre, and what we're going to do now is I'm going to show you how you can make your very own rocket. Parents, don't be alarmed, there's no jet fuel involved in this one. No, today what we are going to do is we are going to make a rocket out of recycled materials. You ready? Let's go for it. So, first thing you're going to need is the body of your rocket. Now, at the Rediscovery Centre, welcome along to our Sustainable Space event. My name is Ali from the education team here at the Rediscovery Centre, and what we're going to do now is I'm going to show you how you can make your very own rocket. Parents, don't be alarmed, there's no jet fuel involved in this one. No, today what we are going to do is we are going to make a rocket out of recycled materials. You ready? Let's go for it. So, first thing you're going to need is the body of your rocket. Now, at the Rediscovery Centre, we love a little bit of reuse, a little bit of upcycling. So, the materials you're going to use today are things that you can find around the house, or probably actually in your recycling bin. So, first thing you're going to need is a tube. This could be a kitchen roll tube, it could be 2 toilet roll tubes stuck together, whatever you can find around the house. Maybe you have some foam insulation tubing around the house. If you have that, that's fantastic. If you don't, that's totally okay too. This is all about using what you have around the house. So, starting off with the body of your rocket. It's not gonna fly very well as it is it? I mean, it's great for looking through, but it's certainly not gonna fly on its own. So, what we need now is some kind of fuel or propulsion method. Now, parents, again, I promise you, no jet fuel. Nope. What we're going to use for this is a simple old elastic band. An elastic band is a great example of an energy conversion. So when an elastic band is stretched, it's got what we call potential energy. It's energy that is waiting to do work. It is stored potential energy. It is absolutely just dying to fly across the room. When we release our elastic band, we convert that stored potential energy into kinetic energy, or the energy of movement. And it's that energy of movement that we're going to use to move our rocket. So, this is going to be our fuel. What we need to do first is we need to attach that to the body of our rocket. And to do that, we're going to use some tape. So, grab yourself a piece of tape, and you're going to pass it through the center of your elastic band. So you should have something that looks a little bit like this. Now, you're going to attach that to one end of your toilet roll tubes or your kitchen roll tubes. This can be a bit fiddly, so it can be handy to have a second pair of hands. So it just needs to look something a little bit like that. Now, we certainly don't want our rocket falling apart mid-flight. I don't think our astronauts would be very happy with that. So it might be worth adding a few extra pieces of tape just to make sure it's extra secure. So we can pass another piece of tape through our elastic band there like that. Okay, and then to make it extra secure, even though it seems pretty solid right now, what you can also do is take a longer piece of tape and you can just wrap it around the end of your tube like that, just to keep those other pieces of tape in place, so that this is going absolutely nowhere except where we want it to. So you can see you can pull on your elastic band like that, and technically your rocket is ready to go. But we want to encourage you to be as creative as you possibly can with your rocket. So get creative and start decorating. You might draw some pictures on your rocket, you might paint it, you might cut out pictures from old magazines and stick them on, whatever you're feeling. Today I'm going to show you how you can make some fins for your rocket, because I don't think NASA's rockets look quite like this. They need a very long elastic band. So we're going to make some fins. Now to make some fins, again, you're going to use some recycled materials, like a piece of thin cardboard. We cut this out from a cereal box. So cut out a square of cardboard, and what you're going to need to do then is you're going to need to make 2 triangles. The easiest way to make 2 triangles from a square is to cut it in half diagonally. So grab a pair of scissors. You might need to get an adult to help you with this. Grab a pair of scissors and cut your square of cardboard in half, so you end up with 2 triangles. Easy peasy. Next thing you gotta do is fold those triangles in half, just like that. So it can be handy if you draw a little dotted line through your triangle, fold it in half. So now your triangle of cardboard can become 2 fins. So next, attach your fins to your rocket. What works quite well for this is if you cut 4 slits at the bottom of your tube. So the other end from where the elastic band went, just cut 4 slits. Try and space them out as evenly as you can and make them all roughly the same length. But you're going to cut 4 slits in the bottom of your rocket like this. Then you can just slot your fins into those slits that you just made, like that. And you can do the same with the other one. So keep the fold of the triangle on the inside and just slot your fins up like that. And now you have got 4 fins attached to your rocket. So you can add a little bit of tape on there if you want. You can put some tape across the bottom here just to keep those fins in place. And that is a pretty good looking rocket if you ask me. Now for the launch. For your launch, you're just going to need a ruler. A longer ruler is easier for this. You can use a short ruler, but it's just a little bit trickier. What you need to do is you're going to hold your ruler at an angle. Experiment with different angles to see which makes your rocket go higher or go further. That's something that you guys can investigate yourselves. So with your ruler at an angle, you're going to loop your elastic band over the corner like that. And then you're going to stretch it back. The good thing about the ruler is that you can measure how far you're stretching back your rocket. What's handy here is just hold where you're going to hold your rocket. If you hold your rocket here and it flies forward, your hands are going to get in the way of the fins. So loop the elastic band around your ruler, change your angle, hold it at the bottom here, pull back, and then let it fly. That went pretty far. It did hit the wall. So maybe try this one outside. Recommend you try this one outside. Do take in mind wind and weather conditions, and always make sure that you never ever launch your rocket towards a person. So get out there, guys, get creative, reuse and upcycle to make your very own rocket. If you do make a rocket, be sure to take lots of pictures and videos of your launches and send them to us on social media. You'll find all the handles at the end of the video. Guys, I hope you enjoyed it and can't wait to see those rockets. It's time to blast off. Thank you very much, Past Ali, for that lesson on how to make your own sustainable rocket. So there's great questions that's come into the chat here from PD and Alice, who would like to know, if the moon is made of cheese, what flavored cheese do I think it tastes of? Well, with all those craters and all those holes, it's got to be some kind of Swiss cheese, although Brie and Camembert are my favorite cheeses. But what we're going to do then is, with our rocket, we're going to have to blast off to the moon to find out exactly what kind of cheese it tastes like. But we're going to have to try and land safely on the moon or on our other planet, which leads us very nicely into our next craft, where again, Past Ali is going to set you guys a challenge to build your very own space lander. Tune in for this. What's up everybody, it's Ali here from the Rediscovery Centre coming to you as part of our Sustainable Space event, and I have a challenge for you. Now, when it comes to space travel, getting into space is actually the easy part, but whether you're landing astronauts on the moon or touching robots down on Mars, landing is hard. Space equipment and the astronauts themselves are very precious items. They can cost a huge amount of money, use lots of different materials and resources, and we really can't just be letting them smash into lots of teeny tiny pieces or explode, because that wouldn't be very good for them or for the planet. We want all of our equipment to be designed so it can be reused and so it actually works. Now that is where you come in. Your challenge is to design a device that will let your astronaut land safely on a new planet. Your astronaut, I hear you ask? Well, here at the Rediscovery Centre, we don't yoke around when it comes to space exploration. Your astronaut, or should I say, your eggstronaut, is an egg. We want you to use whatever you can find around the house to build a lander to protect your astronaut in a landing, just like space agencies like NASA and ESA do. Now, they use all sorts of things to help land smoothly and safely. Parachutes, jet rockets, airbag cushions. They even design craft with wings that can just glide down to the surface. Now, there's a few things you need to consider when landing something on another planet or on the moon. The first is the planet's force of gravity. Gravity is the force that makes things drop. It's what pulls you back down towards the ground when you jump up in the air. The sun's gravity pulls all the planets towards it, which is why planet Earth doesn't simply just fly off into outer space, never to be seen again. And the force of gravity can be different on different planets, depending on their size. For example, the force of gravity on Mars is lower, meaning you'd be able to jump higher and fall slower, but the force of gravity on Jupiter is so strong that it would just crush you instantly. Gravity is going to change how quickly your astronaut hurtles towards the ground. The second thing to think about is a planet's atmosphere. An atmosphere is a layer of gases which surround a planet. Our atmosphere contains the air we breathe, protects us from the sun's radiation, and keeps our planet at a cozy average temperature of 15 degrees Celsius. Without it, we'd freeze. Now, an atmosphere will slow down the fall of an object because of something called air resistance. As gravity pulls an object down, air resistance pushes it back up. Let's test this out. Here I've got two pieces of paper, and you can try this one at home too. Scrunch one piece of paper into a ball and leave the other one flat. Hold your arms out straight in front of you and drop them both at the exact same time. Which one falls slower? The flat piece of paper falls slower because it's got a larger surface area, so more air gets trapped underneath it, pushing it up as it falls. This is why parachutes work so well for people going skydiving, and also why NASA and ESA use them for their landers. The thinner the atmosphere on a planet, the less air resistance there'll be, and the faster the object will drop. Like on Mars, where the atmosphere is 100 times thinner than our atmosphere here on Earth. On our moon and on planet Mercury, there is hardly any atmosphere at all, so there's no slowing down objects using parachutes there. Okay, so once you've thought about gravity and air resistance, it's time to start designing your lander. Remember, you can use whatever you can find around your house. The more stuff you can reuse, the better. We're going to use the engineering design process here to help us plan out our idea. First, identify the problem. The problem here is that if we just drop our astronaut without any protection, it's going to break. And then there'd be egg all over our face and the table. Next, identify constraints on your design. Our rule here is that you can only use what you can find around your house or school, but always ask an adult's permission before using anything. Now comes the fun part, brainstorming. Get creative and think of as many different designs as you can for your lander. It's a great idea to draw out your designs at this stage, and we would love to see your drawings too. Once you've picked your design, get building. This is really, really good fun, and you can get your friends and family involved here too, so you can bounce ideas off each other and use everyone's brains all at once. Next, test. Starting at a small height, drop your design and see if your astronaut survives. If you're feeling brave, go higher. Make sure to get an adult to do any of the really high drops here though, because we don't want anybody getting hurt before their big trip to space. You also might want to do this one outside. Evaluate how the drop went. Was it a success? Do you need to make any changes? If you do, go back a few steps to the brainstorming phase. Edit your design and then go again. Now, a few hints and tips for when it comes to your design. First, think about the size and shape of your landing surface. Remember, the larger the surface area, the more air resistance there will be. As long as there's an atmosphere, that is. Think about the density of the atmosphere and the level of gravity. Choose a planet that you want to land on and do some research to figure out the conditions there. The thinner the atmosphere, the faster the fall, and the larger a parachute will have to be. For example, if you're going down that road. Here's one lander I designed to give you some ideas. And here is my astronaut, Neil Shellstrong. So what I've done with Neil here is I've used some of the egg cartons that he came in to provide a little bit of cushioning, and he's going into our paper cup lander here. I've attached a rather large parachute here to try and get as much of that air resistance as possible, and for a nice cushioned landing, I've put a little bit of foam on the bottom. Make sure to share your designs with us on social media. We'd absolutely love to see them and to see the drops in action. So get out there and get cracking. Or hopefully not cracking. It's time to get out and search for some extraterrestrial life. Now, I was going to apologise for all of the puns, but it looks like in the chat I've got some stiff competition here. Some people camembert those cheese jokes from earlier. They think that building a lander seems like an excellent idea and a cracking activity. Declan's scrambling to get his own egg jokes in there, and Charlie hopes the astronaut lands sunny side up. So I think we're in good company here when it comes to the whole realm of puns. But we're going to move swiftly onwards to our next segment of today's event. So we're going to pass over to Anna Taylor, who is our space junk expert from Armagh Observatory and Planetarium, which is the longest running planetarium in the UK and Ireland. So before Anna comes on board and starts telling us exactly what space junk is, we're going to watch a super quick video to give you guys a taste of exactly what goes on over at Armagh Observatory and Planetarium. So sit back, relax, and enjoy this one.
Let me introduce you to the Armagh Observatory and Planetarium, a very special place. Here, research and education, history and heritage all come together. There's nowhere else like it in the world. We've been exploring the cosmos since 1790. We have been at the forefront of science since the Age of Enlightenment. We have made fundamental contributions to the field of astronomy, to understanding our place in the universe. We are a jewel in the crown of Armagh and Ireland, and recognised in the field of astronomy throughout the world. We have inspired over 1 million schoolchildren in our planetarium. We have graduated 74 PhDs, working in partnership with universities throughout the UK and Ireland. Collaboration is in our DNA. We've been doing it since the 1800s with partners from across the country and around the world. We continually seek out new ways for working with business and the community to tell and explain the stories of science. We're reaching out to new audiences during this time of global challenge. We are a place that we can all be proud of. We are excited to be on the next stage of our journey as one organisation, the Armagh Observatory and Planetarium. There are new opportunities possible for education and for tourism, for contributing to economic growth, for providing the best start in life for our children. We are truly a cross-cutting, cross-border organisation. We can't wait to welcome you back in our planetarium when we can open again. Stay curious.
Hello, Anna. Thank you for joining us this morning. How are you?
Hi, I'm great. Thanks. I'm very excited to be talking to all the future sustainable space travelers out there.
I know, and we definitely. I apologise now for the takeover of puns that I seem to have in the chat here. But 1790, Armagh Planetarium has got a serious history. So it must be really amazing to be a part of that.
Oh yeah, absolutely. It's great because we can see we have documents and everything from then. So it's absolutely brilliant to be able to be part of such a great history.
Amazing. And now, like you're saying, to move into that whole idea of the sustainable space future. So taking what we've learned from the past, from that massive long history.
Absolutely.
I got a question to start. What exactly is space junk?
Well, space junk is basically anything in space that isn't useful anymore. So what I'm going to do is I'm going to share my screen here. Can everyone see that okay?
Make sure you put as many questions as you have for Anna in the chat, and we'll get to as many of them as we can towards the end. Anna, I'll leave you to it and I'll check back in later on.
Brilliant. So we're actually going to cover a few things in this presentation today. We are going to say what exactly is space junk. We're going to find out what the impact is for us on Earth and out there in space, and basically how we get rid of it. So we'll start off with what is space junk, you just asked, and we have been sending satellites and probes into space for a really long time now. It has been over 60 years. The first satellite went out into space called Sputnik 1, sent by the Soviet Union in 1957. So that was our first ever satellite, and unfortunately it isn't still out there. But there are some really old ones that still are. What happens to these objects when we're finished with them? Well, the answer for a lot of these things is that they end up just being junk. So space junk is anything artificial in space that's no longer useful, which includes old spacecraft, broken up parts of spacecrafts, and abandoned launch stages, and basically a whole lot more. There's lots of space junk in orbit around the Earth, and actually on other planets, on the Moon and on Mars. So if we talk about in orbit, first of all, this is the one that's probably going to have the most impact on us. There are an estimated 20,000 artificial objects in orbit. But that isn't actually a correct number. That is a low estimate, because what happens is those are the only objects that are big enough to be tracked. So we have smaller objects, less than 10 centimeters, loads of minuscule little things out there that actually have a big impact on us in space. Little bits of dust and paint flecks and things like that, they don't matter so much on Earth, but in space, they really do. So we'll go through a couple of the types of the space junk that we have. Again, we have dead spacecraft. So this one over here in the top right is called Vanguard 1. It was the fourth satellite to be sent into the orbit around the Earth, and it is the oldest man-made object still in orbit. So it was launched quite soon after Sputnik 1. It was in 1958. And the stages that were used to get it up there, rocket stages that blast off at different times to give it a boost out of Earth's atmosphere, they remain in orbit right now. We also have an interesting Russian one called Cosmos 1300. It launched in 1981, a little bit more recent, but it was estimated to weigh 2 tons, and it only had a lifetime of 2 months. It's been there ever since. So that's well over 30 years. And it only lasted 2 months, and it's been there ever since. Now, this one's quite interesting. Space debris can include things lost by astronauts in space. So astronauts, since the Apollo program, have been going on spacewalks or extravehicular activities, or EVAs, and they have basically dropped things. So it includes a glove lost by astronaut Ed White on the first American spacewalk. Michael Collins lost a camera when he was on Gemini. There was a thermal blanket during some of the space shuttle launches. There have been literally bags of rubbish that Russia just launched into space to get rid of them during their time on the space station Mir. There's even a toothbrush in space that was dropped during an EVA. So we also have tool bags, pliers, various little things that have been lost into space throughout the time we've been spending in space. Now, this one's quite a big one, booster stages. So as I'm sure many of you know, it takes a number of fuel stages to get a rocket out of Earth's atmosphere. We have a reasonable amount of gravity on Earth that keeps things down, especially things as heavy as rockets. And so we have launch stages that blast off at different times throughout its launch to get it out of the atmosphere and into space. Now, some of these stages fall back to Earth when they remain in orbit, so the lower stages, like the Space Shuttle solid rocket boosters or the Saturn V launch vehicle, they don't reach orbit. But the upper stages that are fired off later to get them right out of the atmosphere, they do remain in orbit as debris. So there's quite a lot of that out there. Now, here's an interesting one. There's also been weapons put out into space. Now, this was actually an attempt at something trying to get rid of space junk. The US and the Soviet Union both tested out weapons to break up old satellites. But really what happened was it just broke it up into smaller parts. Didn't really get rid of the debris. So again, more debris can be created when fuel tanks explode, whether that's deliberately to try and get rid of them or basically just when the shuttle stages, when the booster stages are in orbit, they can explode with all the leftover fuel in them and create more debris. So that would be caused by pressure buildup in the discarded rocket stages. And NASA and the US Air Force now require that fuel to be drained at the end of the booster stage's life. But many other countries are still launching things into space that don't have this built in. So they can explode once the pressure builds up. Now, this is all very well, but what is actually happening because of this space junk? Now, it can be a danger to active satellites and spacecraft. In space, you can collide, things can collide together. They're getting, the more space junk there is in space, the higher the chance of collision. And so the more space junk we have out there, the bigger a problem this is going to be. So many spacecraft nowadays are powered by solar panels. Great way to power a spacecraft rather than using fossil fuels, especially because they're out where the sun is very strong. But these areas, the solar panel areas on spacecrafts are vulnerable. They're exposed and vulnerable to collisions with debris. So even small collisions can cause problems by exposing the panels to a cloud of plasma. So what happens is the debris will hit into the solar panel at a really high speed and a cloud of plasma will be released, and that shorts out the electricals in the solar panels, rendering them useless. Now, here, this is a very important class of debris, which is small debris. Now, it's known as MMOD, which stands for micrometeoroid and orbital debris. And it is much more dangerous than you might think. So this could be explosion debris, paint flecks, solid rocket exhaust particles, and micrometeoroids, the tiny little bits of dust and rock that are in orbit around Earth from further out in space. So again, MMOD can be created when fuel tanks explode or satellites are deliberately destroyed, or they can be actually natural. But while the micrometeoroids don't count as space junk, they're grouped in with it because it can cause the same sort of damage. So one of the risks is that these micrometeoroids and orbital debris can act like sandpaper. Now, we've known about this for a while. The ISS does have special shielding to protect the main parts of the craft, but again, the solar panels are exposed, and it just means that we have to put really thick shielding around our spacecrafts so that the micrometeoroids don't wear it down like sandpaper. So we've got a little example here of someone using excuse me while I just do the video here. Someone using this interesting method using sandblasting, which is similar in effect to these tiny bits of debris. And you can see that the surface of this drum here is being blasted clean. Now that's getting rid of rust and paint and everything like that. And while on Earth it can have great applications like this, when we don't want it to happen, it can be very harmful. So again, the ISS has certain parts like the solar panels that can't be protected, and the damage over the years to the ISS has been significant. So even small debris such as plaques can cause significant damage. On the Space Shuttle Challenger second flight, a fleck of paint struck its front window and a pit was created that was over 1 millimeter deep. So you can imagine that, a tiny paint fleck that would do barely any damage on Earth. You wouldn't think of it as something dangerous, but because it's traveling so fast in space and there's no gravity to slow it down, it is really, really dangerous. Now, how we prevent this is the dangers to uncrewed, we're going to look now at the dangers to uncrewed spacecraft. So they're susceptible to collisions because they orbit the Earth on the same path every time. And certain paths are more crowded now than others. So for example, there is the path around the equator that is full of satellites because it's a very useful path for surveying the Earth. It's called geostationary. Costly collisions have already happened, and here are just some of the spacecraft that have been affected by collisions. So there is Cosmos 1275. It was actually lost. It broke up into 300 new objects, and we lost track of all of those. We don't know exactly what hit that, but that was caused by a collision. We have Terra, which suffered a single battery cell failure anomaly. Now, some people think that might have been spontaneous, but we think now that it was probably that micrometeoroid and orbital debris sandblasting the surface of this spacecraft. And the big one in the middle here, Cosmos 2251 and Iridium 33, this is actually two spacecraft that hit into each other. So this happened in 2009, and Cosmos 2251 is an old satellite, was no longer operational, but Iridium 33 was. Altogether, they weighed 2,000 kilograms, and they collided 800 kilometers over northern Siberia. Both satellites were destroyed, and thousands of new pieces of smaller debris were created. Now, crewed spacecraft have a slightly different, debris has quite a different effect on crewed spacecraft. So we have damage to the outside of spacecraft as with uncrewed. And again, especially when you're trying to protect that precious cargo of people, we try and shield the spacecraft using something called Whipple shielding, particularly good against that small debris. But larger collisions can knock ships off their course, and smaller ones to the life support systems. So again, the higher risk of collisions when there's more debris up there mean that some areas in space are now completely crowded, and it makes them unusable. So that area of space can no longer be used by satellites. And this leads to something called Kessler syndrome. Now, that sounds like a fancy disease, but actually happens. It's a bit of a snowball effect. So the more debris there is, the more collisions there are, which creates new smaller debris, which is more debris, and even more collisions happen. And it just snowballs like that. It's a cascade effect that means that it keeps on going forever and ever. More and more debris, more and more collisions. Now, the hazards to Earth. Most debris falling to the Earth does burn up in the atmosphere, but a significant amount can survive. Bigger pieces can survive, and they've even harmed humans. So, an average of 1 piece of debris a day has fallen to Earth over the last 50 years. In 1969, 5 sailors on a Japanese ship were injured when space debris from what was believed to be a Soviet spacecraft struck the deck of their boat. In 1997, an Oklahoma woman called Lottie Williams was hit. Now, luckily, she wasn't injured. It was a small piece of metallic material confirmed as part of the Delta II rocket, which the US Air Force launched as a satellite the year before. So this was something nice and small and light that made it through Earth's atmosphere and landed on this woman's shoulder. Very luckily, she wasn't injured. But a 6-year-old boy in 2002 was injured. He was the first person ever to be injured by space debris. And again, I think he was quite lucky. He suffered a fractured toe and a bruise on his forehead. So thankfully, nothing too serious. But again, this was a block of aluminium. So 80 centimeters by 50 centimeters, weighing 10 kilograms. It's quite a surprise that that was all he suffered. But he has the distinction of being the first person ever to get hit by space debris as he sat beneath a tree in China. There have been vessels landing in farm fields. From 1969 to 2021, there have been examples of space debris returning to Earth and causing damage to property and people. So, here's the important question. How do we stop this happening? Now, there are a few different things we can do. We can try and avoid damage to spacecraft. So, here we move the spacecraft, fairly easy solution, and to avoid large debris. Now, this is all well and good. We can do that if the surrounding debris is constantly monitored and we know it's coming. So that requires a huge amount of energy and effort going into monitoring every single bit of space debris out there. And remember that it was 20,000 objects in space, and that was just the objects over 10 centimeters. So it would be very, very hard to do that. And even if we think we've got it all covered, there might just be something that we've missed that comes hurtling in there out of nowhere. So you have to have very quick reactions if you want that to happen, but usually we have to be monitoring these debris. Manned spacecraft then, Mir and the ISS, have been moved in the past to avoid large debris. The little pieces, the micrometeoroids and orbital debris, they're not big enough to be moved to cause the ISS to move, but the ISS has moved over 16 times in its life. Sometimes when the threat of debris is high and we think that we can't move a spacecraft, or even if we move the spacecraft, it'll still get a little bit of a hit, astronauts have been asked to move to more sheltered parts of the ISS. So bits with thicker shielding, they go and hide in their little shielded dome to prevent any harm coming to them. Now, this requires, again, that we track debris. So we can track it from the ground or we can track it from space. Something called the US Strategic Command does keep a catalogue of known orbital objects, and that uses ground-based radar and telescopes. One space-based telescope And the 2009 edition listed 19,000 objects. The ESA also has a space debris telescope, and it brings data to us all the time. Again, though, this is larger objects, and it can be a useful early warning system, but it might not prevent every single collision. Now, here's where it gets interesting. How do we actually remove debris that is already there? Now, there are loads of options. Pretty much anything you can think of that would get rid of space debris is an option. So we have self-removal. Some satellites move to a different orbit at the end of their lives that isn't useful for satellite monitoring. So it's called a graveyard orbit. Now, the satellite is programmed to move to this orbit so that it won't get in the way of any active satellites. We have some methods of increasing the orbital decay rate. Now, what it means there is that they gradually fall back to Earth. So rather than load the spacecraft with rockets that would have to fire at the end of the night, at the end of its life, an electrodynamic tether could be attached to a spacecraft at launch. Now, what happens here is the tether would act pretty much like a parachute. It would roll out and slow the spacecraft. And when a spacecraft slows, it starts to fall. So it would eventually decay, its orbit would decay, and it would fall back down to Earth. And again, that would have to be carefully monitored to make sure it's not falling and harming someone. So again, sails have been suggested, balloons, anything that can slow an object down to get it to fall back to Earth. We also have external removal. Now, external removal means another object is being used to remove debris. So we've had drones, remote-controlled vehicles. The ESA awarded a contract to a company in 2019 to clean up space debris specifically, and it used a little robot that has 4 arms, and it grabs the junk and it drags it back down into Earth's atmosphere. Now, what happens when they get to Earth's atmosphere is that the robot that's made for getting rid of the debris and the debris itself will burn up in the atmosphere, which will get rid of it pretty much entirely. Now, lasers have also been used. I know this sounds like a sci-fi film, but the laser broom uses a ground-based laser to break up the front of the debris. And what happens there, it causes a tiny little explosion, and that slows the object down. And one of my favorites is nets. You can literally put out a huge net, just like fishing, to grab space debris and pull it down. Now, the Japanese Aerospace Exploration Agency have tested this, but it was literally only a test. They haven't succeeded in any actual cleanup. And last of all, someone has even suggested using a harpoon, firing a harpoon out into space to try and hit some debris and pull it back to Earth. That's pretty wacky. So, what is the future of space junk? We have lots of ideas that might be interesting. We will have to remove space junk if we want to keep using space the way we do. We don't want any places in space to become impassable or unusable. And so future spacecraft will, at the very least, have built-in growth mitigation. Now, what that means is that they won't explode and they'll remain as one big object of debris rather than smaller ones. And again, going back to some of those things that we mentioned, some might even have self-removal systems. There are likely to be international regulations introduced The United Nations already has recommendations. They aren't compulsory at the minute, but in the future they might become requirements for anyone using space. But this is basically the future of space junk. Anyone here, as I said, future sustainable space travelers, future sustainable astronauts, even astronomers might, if you've got any ideas of how to bring space junk back to Earth, we are more than willing to hear it. And I think you might, if you come up on a great idea, you should absolutely go for it. Now, that is my presentation done. So I am happy to take any questions that anyone might have. I think Alice might help me in that respect.
Thank you so much for that. Like, I learned loads there as well, which is brilliant. It's great. It's kind of terrifying to think that, you know, we don't really have estimates of how much is actually out there if we're kind of only measuring the bigger pieces, as you say. So, you know, it is definitely a really, really huge problem. So if anyone has any ideas, as wacky as they may be, of how to tackle the issue of space junk, definitely pop them in the chat, because we've got some very good questions coming into the chat. So I'm sure we'd also have lots of very good ideas of how to deal with the problem coming in. And obviously what's great now is from your talk, Anna, we understand what space junk is. And in order to solve a problem, we need to understand the problem first to come up with what may actually work. And we did have some great questions coming in, Anna, if you don't mind.
Okay.
A few of them. Some of them we did touch on a little bit there. Like Marie was asking, does space junk, or can space junk fall down to planet Earth? It's crazy that, you know, it took until 2002 for someone to be hit by it, which shows we are probably pretty safe.
Yeah, it's rare enough, certainly. If you think about even natural stuff, there's only ever been one person hit by a meteorite, and she got away with a bruise. And you can consider how many millions of meteorites there are out in the space in the solar system. It's quite a rare incident. But the more space debris we have up there, the more likely it'll become. Totally,
yeah, that makes sense. As Sarah was saying, we learned from Sarah earlier on, you know, our atmosphere does protect us from a lot of these things, both, you know, the naturally occurring things like our meteorites right through to our space junk. Aoife was asking, are some kinds of space junk more harmful than others, or potentially more harmful than others?
So, yeah, I think anything that has the ability to explode, pretty much. Now, that would be dangerous on Earth, obviously, but up in space, it just creates, aside from the risk to humans, which is admittedly small, it's more of a risk to our future space travel.
Okay.
So we love being able to go out and explore space. The world is absolutely on that track. People are spending huge amounts of money on getting out there.
Yeah.
So we won't be able to continue doing that if some of the more dangerous types of space junk are out there. If, for example, a huge booster stage were to explode in our atmosphere, or outside our atmosphere in a particularly useful area, we might not be able to use that until it's been cleared up, because there's risk of collision is too high.
Yeah, so obviously, like you're saying, more and more people are going into space now, especially with the commercial space travel, as well as, you know, the classic space agencies like NASA and ESA. So a lot of us theoretically someday could get to the moon. Is there space junk on the moon? And is, you know, space junk that's stationary on a surface, is that easier to clean up than what's kind of circling around? That's one question that came into us from Charlie.
Okay, that's a really good question. It's one of my favorite things to talk about, actually, because there is a lot of stuff left on the moon. So the moon is the only object, the only place outside of Earth that humans have actually been to. And it was in the 60s and early 70s, which meant that everything was really new, really expensive, and very, very difficult and dangerous. Now, we've been living in space for 20 years now. Since 2000, there has always been someone in space. So we might be a bit better at it now, which is why why NASA are starting their moon missions again. But what these new astronauts might find on the moon is quite interesting. So we have a packet of wet wipes. That's an interesting one.
A problem here on Earth as well as on the moon.
Absolutely. Litter, yeah. So we've got a hammer, If you might remember, there's a very famous video of an astronaut dropping a hammer and a feather at the same time. Now, it's exactly what you were talking about earlier with the air resistance. And on the moon, there is no air resistance. There's no atmosphere. So the hammer and the feather dropped at the exact same rate.
Amazing.
But that
very cool experiment that we can't really do too easily on Earth without.
Exactly. Yeah. There is a very grainy video taken in the 60s that you can watch.
But they didn't clean up after themselves, is what you're saying.
They left the hammer, basically. Yeah. And do you know what? They might have left the feather.
Okay.
The problem with the lunar landings is that they descended onto the moon in a 15,000 kilogram spacecraft.
Okay.
But the bit that took off was only like 5,000 kilograms. So they had to leave anything that could possibly weigh them down behind.
Oh, okay. That makes
including
sense.
The hammer.
Yeah.
Golf balls. The astronaut.
There were some golf shots taken on the moon.
Yeah, the astronaut Alan Shepard was the first person to ever play a sport on the moon. He snuck up a golf club, and it was great. He tried to hit the first one, but the suit was so bulky he couldn't get his hands together to make a good golf shot.
I was going to ask, was his game better on Earth or on the moon? But clearly, there was some restriction of movement with the suit.
Yeah, his first shot certainly wasn't very good, but apparently his second shot went over 600 kilometers. So on Earth, that would be absolutely spectacular. On the moon, it's obviously to do with the lack of gravity, or the smaller amount of gravity.
Yeah, of course.
But some of the more interesting things left on the moon are some gross things. Bags of human waste.
Lovely.
Poo, pee, vomit. Yeah, because they weren't going to take that back when it was so heavy.
No, waste.
They wouldn't want to have that in your spacecraft that is tiny and you have to live in with two other people for a 2.5 day trip back to Earth.
Yeah, say no more. We understand why they left that behind.
So the astronauts in the Apollo missions basically had to wear nappies. So they're all left behind. Now, they like to call them maximum absorption garments, or MAGs. But that was just really to think so that they weren't quite so embarrassed about wearing nappies.
Fair.
There are 809 objects in total on the moon.
Wow.
And NASA's very good at keeping track of things. They have a catalogue of everything that has been left behind.
It's like flicking through the Argus catalogue, but a little bit less fun, maybe.
Yeah. So all of the interesting spacecraft that we've sent to the moon and Mars, they're all still there. Obviously, they can't return. But there's also the sort of less artificial stuff, the stuff that humans have brought and weren't able to bring back with them. So was it Charlie was asking this question? Yeah. Was absolutely right. It might be a little bit easier to bring back. The problem is the difference between easy and expensive. It will be horrendously expensive. So I think a good way to come up with that is that in the future, hopefully we'll have a base on the moon. I know that NASA is certainly planning a space station around the moon, but potentially more sustainable ways of getting rid of this stuff. Obviously, the human waste is a bit of a sticking point, but I've seen a couple of questions actually about saying using this for future buildings and things like that. That's an absolutely brilliant idea. We've got all the descent stages, so all the bits that took the astronauts down to the moon and were left behind, they're all there containing loads of different parts. And we've got some interesting things that might make an interesting museum for the people who go to the moon in the future.
Again, maybe not the human waste, but everything else.
There's memorials to astronauts who didn't make it. There's peace symbols, and there's American flags and everything like that. So it could be really interesting.
That would be really good. And as you know, like here at the Rediscovery Centre, we love a little bit of reuse. We love a little bit of
absolutely.
Upcycling. So why not reuse all those pieces that are just sitting on the moon, sitting on Mars, and use them again and again as much as possible? We did have a few ideas of how to deal with space junk. There was
brilliant
giant nets. Have giant nets been kind of like, I suppose, like giant fishing nets almost? Have they been?
Yes. Again, Japan has tried briefly.
Okay.
It was an operational test as opposed to something that actually was useful. But hopefully, it was very recent. Hopefully they can sort of develop that. So it is an idea that is in under consideration and is being developed. Yeah, definitely.
Another idea came in from Sheila. Sheila's wondering, is there any way we can kind of direct the space junk or like catapult the space junk towards the sun to have it just be burned up? Is that a feasible or a good idea?
Very interesting. Now, the difficulty there would be getting it out of Earth's gravity altogether.
Okay.
So, because these things are still in orbit around the Earth, they're not in the atmosphere, but they are still bound by Earth's gravity. So you'd have to get them. The equation for getting out of orbit, out of gravity, away from gravity, is basically the faster you go, the easier it is. You have to go fast to get out of gravity.
Yeah.
Which means that these objects would have to be accelerated really fast.
Okay.
Which
so
again,
giant catapult, maybe.
Yeah. Do you know what I was thinking? Like a rocket that had a net on it or something like that. That you could just grab it and send it towards the sun. It's a really good idea. You'd then also have to avoid
could be really
cool.
Yeah.
You'd have to avoid the pull of
here. We can see like this collaboration where people's ideas are kind of coming together, and that's what this, the whole world of space exploration is all about: is people from different backgrounds with different ideas working together to achieve the one goal, which is what we want.
I think that's why ESA is so exciting, with all the different countries contributing. It can have, it's not an island. You can have lots and lots of different ideas coming together.
Yeah, and there is obviously the question then, though, if we're just directing all of that space junk towards the sun, are we wasting valuable resources? Is reusing them better than, again, we burn some of our waste here on Earth? Should we just be burning the space junk, but presumably some that's more useful than others, maybe?
Yeah, I mean, it all comes down to that, I suppose, because the idea of accelerating all the waste towards the sun, while it's very interesting, would be very energetically costly. It would use a lot of energy, a lot of resources, probably fossil fuels. It wouldn't be very sustainable in the way that we think of sustainable energy now on Earth.
Yeah,
I think there has to be sort of different standards for space, though. Do you know what I mean? Like,
yeah, of course.
Once we have clean energy down on Earth that works for everything, absolutely great. We can use that in space too. In the meantime, I think we have to consider what makes space usable for us.
Yeah, of course.
Or stop going to space altogether, which no one wants.
No one wants that. No, we want to be able to sustainably explore our solar system,
exactly, yeah,
the universe. So it's going to be a lot of trial and error, I suppose, with these things, and try and use different ideas and see what's going to work and what's not.
I think
one more question, Anna, here before we wrap up, if that's okay with you. So Aoife has asked, can the ISS protect itself against space debris? Now, obviously, they do have defenses built in. Do we have evidence that those defenses are working? Has it been hit since the defenses went in? What kind of things are we looking at there?
There have been small impacts, yes. The one that's most dangerous to the ISS, because it's in low Earth orbit with fewer other satellites and things like that. That micrometeoroid would be the most impactful, probably, which is the sort of the sandpaper.
Yes.
So it does have special shielding on the non-solar panel bits. The solar panels are sort of the delicate bits. But the ISS, has been moved a number of times. Its orbit has been changed slightly to avoid larger bits of debris.
Okay.
And I think there has been a few collisions that have required, or a few potential collisions. Do you know, like at the minute, well, I suppose there's always sensational news stories about an asteroid coming towards Earth and we have to try and figure out how to destroy it. That sort of thing, where an asteroid or a meteoroid came close, but didn't actually, we weren't sure whether it was going to hit or not. Astronauts have had to take safety measures in the past.
Okay.
Just in case. But any impacts have been small. There have been a couple of breaches to the hull, essentially. I know that's talking as if it's a boat, but there have been little holes made in the outer surface, but thankfully those could be repaired from the inside.
Oh, so, brilliant. Okay. So the repairs are constantly ongoing by
absolutely,
the crew on the ISS.
That's part of the reason why there are so many spacewalks, is to go out and fix the bits of the ISS that need repairing, and
So
to add
maybe
new experiments
you're-
and things like that.
Yeah, so to do experiments, but also I suppose like your own house, there's a lot of maintenance
Maintenance,
that has
yeah,
to be done
yeah.
as you're going along. But as you're saying, ideally avoid collisions rather than testing
Yes.
if the sensors work is kind of the
Yeah,
best.
absolutely, yeah.
Well, Anna, thank you so much for joining us. We learned a huge
Oh, I was
amount
absolutely
about
delighted.
space junk. So it's been a big 60 long years of humans creating space junk. So
Absolutely.
hopefully we can learn from this past a little bit, and hopefully now everyone's aware a little bit more about how we can, prevent space junk. And again, if anybody has any amazing ideas, you could be the person who solves the issue of space junk. So again, Anna, thank you very, very much for joining us, and to the rest of the team at Armagh Observatory and Planetarium. It's been absolutely lovely having you.
Not a problem.
We are going to take a short break here, guys. So be sure to join us back here at 1:30, where we will be joined by engineer, scientist, writer, and performer who is inspiring us all to dream big. So Dr. Niamh Shaw will be joining us here at 1:30. In the meantime, take a break, design some rockets, figure out how to keep your egg landing safe, and we'll see you all again at 1:30. Thanks again, Anna. Thanks very much.
Bye.
Bye now. Join us back here, guys, at 1:30. I'm myself going to go and take a little spacewalk myself. So join us back here at 1:30, where we'll be joined by Dr. Niamh Shaw. See you then.
Women in space. The first woman in space was a Russian woman named Valentina Tereshkova. She was selected out of more than 400 applicants, and then out of 5 finalists, to pilot Vostok 6 on the 16th of June, 1963, becoming both the first woman and the first civilian to fly in space. He orbited Earth 48 times, spent almost 3 days in space, and remains the only woman to have been on a solo space mission. However, Valentina would be the only female astronaut for almost 20 years, until 1982, when another Russian, Svetlana Savitskaya, traveled into space.
In 1983, Sally Ride became the third woman in space, and the first American woman in space. Sally Ride remains the youngest American astronaut to have traveled to space, having done so at the age of 32.
In 1984, a further 3 women entered space in the form of Judith Resnick, Catherine D. Sullivan, and Anna Lee Fisher. Catherine Sullivan's exploration achievements are particularly impressive, as in 2020, she became the first woman to reach the summit of the Mariana Trench, meaning she is the only person in history to perform a spacewalk and reach the depths of the sea.
In 1985, 4 more women entered space: Margaret Reyes Seddon, Shannon Lucid, Bonnie J. Dunbar, and Marielle Cleve. There would then be a 4-year gap of women entering space until 1989, when Ellen S. Baker and Catherine C. Thornton became the 11th and 12th women in space. In 1990, the 13th female astronaut was Martian, She's Out of This World. 1991, seen a further 4 women enter space, including Linda M. Godwin, Helen Sharman, Tamara and Millie Hughes Falford. Here at the Armagh Planetarium, we were lucky enough to interview Helen Sharman, the first British person in space.
If you had one piece of advice for the kids watching, what would that be?
When I was at school, I thought it was impossible to be an astronaut. Nobody from this country had gone into space, therefore it was never going to happen to me. But the world's changing so quickly, and we don't know what's going to happen in the future. There are so many more opportunities now, and there will be even more in the future that we can't even dream of just yet. And I think if we continue to study science, engineering, those kind of subjects, so that we can understand more about the world we live in, we will just put ourselves in a position to be able to make use of so many of those opportunities in the future, and really enjoy exploring a variety of things which will make our life interesting and as exciting as we want it to be.
In 1992, Roberta Bondar, Jan Davis, and Mae Jemison entered space, and in doing so, Mae Jemison became the first Black woman to become an astronaut. And she also holds several honorary doctorates, and has been inducted into the National Women's Hall of Fame, and the International Space Hall of Fame. 1993, seen 4 more women become astronauts, including Susan J. Helms, the woman who completed the longest spacewalk in history, at 8 hours, 56 minutes. Ellen Ochoa, the first Hispanic woman in space, Janice Evas, and Nancy J. Curry. 1994 seen 2 more women become astronauts, including Chiaki Mukai, the first Japanese woman to enter space, and Yelena V. Kondakova. 4 more women became astronauts in 1995, including Eileen Collins, who made space history by becoming the first female shuttle pilot and shuttle commander. Wendy B. Lawrence, Mary E. Weber, and Catherine Coleman. In 1996, Claudie Hague-Nier became the first French woman to work as an astronaut, as well as the first European woman to visit the International Space Station. Between 1997 and 2000, 6 more women explored space, including Susan Still-Keelrain, the second ever female shuttle pilot; Kalpana Chawla, the first ever Indian woman in space; Catherine P. Heyer, Janet L. Kavandi, Julie Payette, and Pamela Melroy, the second ever female shuttle commander. 2002 would see another 2 female astronauts leave the stratosphere, Peggy Whitson and Sandra Magnus. Peggy Whitson's achievements truly are astronomical. She is the oldest female astronaut ever. She has completed the most spacewalks by a woman. She was the first female ISS commander, and she has spent more time in space than any American astronaut. In 2003, Laurel B. Clark entered space as part of the STS-107 mission. However, this would end in tragedy, as it was the 28th and final flight of Space Shuttle Columbia, as the shuttle disintegrated in re-entry into the Earth's orbit. Laurel and 6 other crew members died, and it remains as one of the biggest tragedies in NASA's history. Following the Columbia disaster, there was a 3-year hiatus in NASA's Space Shuttle program, and it wasn't until 2006 when the 41st female entered space, Stephanie Wilson, who has spent more time in space than any other Black woman at 42 days. Stephanie was joined by 5 other female astronauts that year, including Lisa Novak, Haida Marie M. Stephanie Shin Piper, Anusha Ansari, who became the first female space tourist and first Iranian in space, Sunita Williams, and Joan Higginbottom. Between 2007 and 2010, a further 9 women explored space for the first time, including Tracy Caldwell Dyson, the first woman born after the Apollo 11 flight; Barbara Morgan, who was the oldest woman in space at the time of her first mission, aged 55; Yi So-yeon, the first Korean in space; Karen L. Newberg, K. Megan MacArthur, Nicole P. Stott, Dorothy Metcalf Lindenberger, Naoko Yamasaki, and Shannon Walker. It wasn't until 2012 when the first Chinese woman had entered space, when Liu Yan became an astronaut, and this was quickly followed by the second Chinese woman in space, as in 2013, Wang Yaping entered space to celebrate the 50th anniversary of Vostok 6, the first spaceflight by a woman. 2014 seen another 2 women leave Earth's atmosphere for the first time, Yelena Sereva, who became the first Russian woman to visit the International Space Station, and Samantha Cristoforetti, who became the first Italian woman in space. Between 2015 and 2017, only 1 woman entered space for the first time, and this was Kathleen Rubins, in 2016, who became the 60th female astronaut in the process. Between 2018 and 2019, 5 more women became astronauts, with Serena Aunan Chancellor and Anne McClain entering space in 2018. 2019 seen Beth Moses fly into space as part of the VSS Unity VF-01, a spaceflight operated by Virgin Galactic, and in doing so Beth became the first woman to make a spaceflight on a commercially launched vehicle. 2019 also seen the 64th woman in space, who was Christina Koch, and the 65th woman in space, Jessica Meir. Christina and Jessica made history together as they became the first 2 women to undertake an all-female spacewalk during the ISS Expedition 61. Christina also holds the record of the most continuous number of days in space for a female. COVID-19 halted the entire world in 2020, including space travel. However, 2021 has been very prosperous for space travel, which has coincided with 4 women traveling into space so far this year, including Sarisha Bandla, Vice President of Virgin Galactic, as part of the Virgin Galactic Unity 22 flight. Wally Funk, who flew in the Blue Origin NS-16, alongside billionaire Jeff Bezos, became the oldest woman ever in space, aged 82. And just a few weeks ago on the 16th of September, the 68th and 69th female astronauts, Son Proctor and Haley Arsenault, entered space together as part of the Inspiration 4, which was the first human spaceflight to orbit Earth with only private citizens on board. From the first female astronaut, Valentina Tereshkova in 1963, to Haley Arsenault in September 2021, there has been a total of 69 incredible women who dared to leave the comfort of Earth and explore space for themselves. And with the advancements in technology we have seen in the past 58 years, the future is even more promising. And now we ask the question, who will be the next astronaut to enter space? Could it be you?
Welcome back, everybody. Hope everyone enjoyed their little break. We are delighted now to be joined by Dr. Niamh Shaw, who's going to join us and tell us all about her love of space and what's been inspiring her to shoot, dream big and think about how she herself could possibly get to space one day. So delighted to welcome Niamh Shaw here with us today. Niamh, how are you today?
I'm great, Ali, and congratulations on your first virtual space sustainability event. I think it's brilliant.
Thank you. Yeah, I've had great fun so far.
I've been listening in. Yeah, it's brilliant. Brilliant. Thank you so much for asking me to be a part of it. I'm so excited.
Delighted to have you. Now, Niamh, engineer, scientist, writer, performer, artist in residence, SFI award winner. Is there anything you can't do?
I'm not a good swimmer, Ali. I'm not.
Oh, okay.
And
and
I'm not good at sports.
Okay. And some people may also recognize you from some TV appearances. So the Late Late Show at RTE's Homeschool Club as well, I believe.
That's right, where we filmed in your very centre last year when the world was in lockdown. We used to head Rediscovery Centre and we used to film our shows from there. So I loved being out there. The centre is brilliant, and if you haven't checked it out, people, go see it. It's brilliant.
Well, it's great to have you back with us, albeit obviously virtually yet again. So Niamh, today I believe you're going to tell us all about your love of space, and tell us, what age did you actually become interested in the whole realm of space?
8. I was 8 years old. 8. Yeah, I'm going to tell people exactly. I'm going to tell people all about that now, and then kind of take them on a whistle-stop tour of some of the more exciting videos of adventures that I've been on, because I just thought, really interesting videos today, because I don't have class, so I know I don't have much time. So yeah.
Okay, Niamh, well, in that case, I'll leave it to it. Again, if anyone has any questions for Niamh, please do pop them in the chat, and Niamh will get through as many of them as we can at the end. That suits you.
I will.
Sweet.
I will.
Okay,
I will. I'll talk for about thank you, Ali. Thanks, everybody. I'm delighted to be here with you today. I'm just so happy. And yeah, if you have questions, what I'll do is I'll talk for about 15 or 20 minutes, and then I'll keep an eye on the questions, and anything that comes in, I'll take my time to answer them. So I've got a few slides, so I'm going to share my slides. Years old. Somebody had showed me that slide. It's really about thinking about what you want to do with your life and being curious. I'm going to turn my sound off. How do I sound off? How do I turn my sound off? I can get feedback. If I mute myself, will you be able to hear me? Can you hear me now? I don't know if you can hear me now. Let me see. Oh, I don't know how to mute myself. I don't know how to mute myself. Ali, what will I do?
Hear you there. There is a little echo. We'll work on that for a couple seconds anyway. I'm going to record it for you, okay?
Well, will I just share my own slides? Let's see if I can see my slides away. Let me share my own slides. That might be the easiest thing to do. Can we try that? Nice. Let's see. We'll get there, guys. We'll get there, guys. Weird echo. I can hear myself. Weird. This is what happens. This is what live events are all about. And that's okay. So I can still hear myself. I'm just going to stop. Okay. Right. I'm going to put headphones on. I'm just going to not listen to my headphones. So if you go to the next slide, please. I want to show you what I do. So I'm really lucky now. I have a job where I get to talk to people all around the world about my passions. I love it. I get to talk at events. Oh, great. Cool. Can you go to the next slide then, please? If we go to the next slide, I want to show people some of the pictures of what I do. And if you just press the space bar, then they should just automatically toggle from then on in. I've just got a load of slides I want to show you. I'm somebody that loves technology, but I also love talking, and I also love performing and acting and writing. So what I do is I put the whole lot of that together, and I think about other ways of bringing space and science to new types of people, and people who feel that space isn't for them. And then, of course, just like Ali said to you, because of lockdown last year, then I got to be on TV and talk to a whole new group of people much younger, and talk about my passion for space, which is great. And the next slide then, that'd be great. So I'm talking to you today from here. I am not in Ireland. I live now in Strasbourg in France, and I'm based at the International Space University. And I'm there because I want to learn more about space, and I want to get to know more people who are involved in space, so I can bring all that information back to Ireland for you to make more interesting talks, and for me to eventually get to space myself. So if we go to the next slide, because when I was 8 years old, this is me, and they're my family. So we were feds. If there's any out there, I feel your pain. We were never allowed to kind of hang out together in groups, because the more gingers that are together, the you have of people laughing at you. So I've an older brother and another sister, and they were gingers. And then my younger brother, he got away with he didn't have red hair, so he didn't bully half as much as we did. But we traveled around a lot, and I loved school. I absolutely loved it. And we were into science and space in our house. Slide. I was doing a summer project about the planet Saturn, and I was looking up information about it, and I came across this picture for the very first time, and I was like, oh my gosh, that was the first time I saw Earth, like from far away and from the viewpoint of the moon. And I was like, oh my God, like I want to achieve that in my life. I want to stand on the moon, and I want to see the Earth. I want to be able to kind of get it into, I want to be able to capture it in my thumb. And that is a big goal. And that picture was taken years ago, 52 years ago. It was taken by the people who were preparing for us to ultimately get 2 people on the moon, which happened the following year. And I wasn't only just affected by that picture. When that picture first came out, the whole world was affected by it. It seemed to make people see that Earth was this really fragile thing, and it was alive. It was alive because there was clouds moving, and they could see oceans, and then they could see the smoke from fires, and people were like, oh my gosh, we have to take care of our planet. So I didn't realize all that when I saw the picture years later, but it really made me go, I want to go to space when I'm older. And then, next slide. What happened then was interesting. As I got older, I didn't really know how I was going to do it. So if you go to the next slide, I didn't know how I was going to achieve it. And there was nobody in Ireland at the time who I knew that was involved in space. I didn't know of any female astronauts. We weren't the family that went to NASA or America, so I never got to go to Kennedy Space Center. And the people that I met now who are Irish, who were involved in space, a lot of them either did that or they knew somebody that was already working in space. So I gave up. I went to college, and I'm very lucky that I went to college, and I studied engineering, which I loved, and then I studied science, but my dream never went away. And I never gave up on it. And so when I started kind of acting and writing, it kind of started coming back. I think when you're creative, your imagination sort of makes you want more, and it makes you realize like that nothing can stop us except, the power of our imagination. And it kind of back. And that go. And since then, I have been on a quest to see if I can get to space. And I've been on amazing space adventures. So let me show you some of the videos of the adventures that I've been on. So if we could please. I studied space with a bunch of people from all over the world back in 2015. And out of that, a lot of the people that were there, they were already working in the space sector. And they wanted to go to this place in the desert in America because it looked like in the middle of it, in Utah, there is this place that you can live as if you're on Mars, and it's called the Mars Desert Research Station. And they invited me to join them. If we just click the next slide, and there they are, and they're from Slovakia and Israel and Australia and France, and they liked the fact that I wrote about space and I was able to perform space, and I wanted to capture an everyday experience because this was completely different to anything I've experienced before. So it was as if we were on Mars, and we were conducting experiments as if we were on Mars, which meant that every time we went outside, we had to wear our own pretend spacesuits. We also had to bring in our water and our own supply of food. So, because that's what it would be like if you lived on Mars. You know, there's nothing on Mars. And we did that for 15 days. So if you go to the next slide, there's a video that should play. That's me walking outside in my spacesuit, and I'm walking towards the house that we lived in as if we were on Mars. It's called a habitat. Anywhere you live that's not on Earth are called habitats. It's like space jargon. So that was our habitat. And it had 2 stories, and this is where you went in and when you went outside and where you conducted experiments. And then upstairs was where we ate and where we slept. And if you press the space bar, you'll see that where we ate, we slept. This is the downstairs of where we lived, and now we're opening the door and we're going into the door that I just went in on the previous video. So you have to have an airlock, and that's like 2 doors, because you want to protect the oxygen that you have inside your house, and when you open the door you don't want it to go outside. And there are the spacesuits, they're all stacked there and they're recharging overnight, and we would stand in there to wear our spacesuits, and you'll see the next video of us putting it on, not just yet, we'll let this video run to the end. And as we go out, you see the pink light there, that was an experiment where we were growing plants using artificial light, pink light. These were this crazy dangerous set of stairs to go up to the place where we lived. And where we lived, we had our own bedroom, we had our own kitchen, and we had our tank of water that we would pump in every day. We had a very limited supply of water. We only could flush the toilet for number 2s and not number 1s. That's Idris, he's from France, so he's working on the computer because we had reports to do every single day. You see the ladder up there? That takes us to the water tank, which we had to pump in from outside every day. And now we're going into my bedroom. It wasn't really like a bedroom. It had no window. It was tiny. I slept on top of a box. I had to bring in all this equipment. So my suitcase was packed with equipment and camera gear and sound recording gear. I brought hardly any of my own stuff with me, just 2 pairs of trousers and 4 tops. That was all I could squeeze in. And on that kitchen table, we would work on our computers. We would have reports to do, and then we would obviously eat. I would eat, this food. You'll see the food now in a second. And this is Michaela showing us the food. We had these tins of dried food. This is dried egg. It was disgusting. We had dried egg, dried butter, dried broccoli, dried raspberries, dried sausage, dried orange. We would add water to things to live. It wasn't very nice. And water was very limited. So you couldn't just, turn on the tap and glug back loads of water, even though I was really thirsty. We had to monitor our water every single day. And the water was forced through the pump, really bad pump. It would make this sound every time we went to flush the toilet, or if we wanted to wash our hands or brush our teeth. I didn't shower the whole time. I took up too much water, and also the pressure was so rubbish. And and I'd wash my hands. I'd wash myself every day with just like a face cloth, and that's just what we did for 2 weeks. And I got used to it really, really quickly. After 5 days, you forget about shops, you forget about television, you forget about everything back on Earth, and you just get used to this lifestyle. And it was, I really liked it, actually. I really liked how simple my life was. So if we go to the next slide, I'll show you the next video of what really made it different more than anything else was when we would have to put these suits on to go outside. You have to get help from your crew. So this is video of Rick, the big tall guy. I have a camera on his forehead, so you're seeing him from the inside of his helmet, and you see that it's all scratchy and stability was really poor. And then we would have a rucksack to put on which had a fan in it that was supposed to keep the inside of the helmet from getting foggy for our breath. It didn't really work very well, so it was very, very dangerous every time we went outside. And the 3 of you you'd have to go in 3 for safety, and you had gloves on and you had heavy boots on, and you couldn't feel the air on your face. You couldn't feel anything. So it felt very much like I was walking on a different planet. It was really scary. It was hard to know where you were going and where you were walking. So you had to get training before you went on your first spacewalk, and you were given very clear instructions never to walk away, to stay with your crew. And when you were driving these ATVs, which are these kind of all-terrain vehicles that you allowed go very fast, and you had to stay in line with the person in front of you. If you were in the middle, you had to keep looking back at the person behind you. If you were behind, you had to stay up with the people. And this is a very straight piece of road. I mean, that's why I was able to film it. But most of the time, you're going over heavy rocks. It was dangerous. And you'll see when we got to the top of these kind of mountains or areas, you'll see by the way I walk that your footing isn't. You can't really see because the helmet, and you kind of have to go forward, and also that it's not hard. The hills and stuff were made of kind of the sandy stuff, so I never knew where I was going. So it was scary. I found it very, very scary, but I really enjoyed the experience. And I remember when I came back to Earth that I appreciated water in a completely new way. I appreciated all the stuff I had in my house, and it made me much more conscious of the way I live today. It made me really think about how to take better care of my planet, because we take so many things about Earth for granted. So the next thing I want to show you is, and there's loads of people there asking questions how to be an astronaut. So I want to show you the next slide. So I got to go to the Space Center in Houston, Johnson Space Center. And if you go to the next slide, this is me pictured in front of the space shuttle, which was amazing. And that's a miniature kind of model of the space shuttle. It's much. And if you go to the next slide, I also got to go to the European Space Agency's astronaut center. If you press the next slide, this is in Germany, and this is where our Europeans train. I watched one particular person train for their upcoming mission in this really deep pool called the Neutral Buoyancy Facility. It's 20 meters deep. And what they do is they use these facilities to help astronauts train folks when they go outside of the International Space Station and they have to fix something, because the only place we can kind of simulate what that's like is underwater. And so they spend hours every single second of every time they're outside of the International Space Station. They have to practice. So it's incredibly. So the person I saw, if you press the next slide for me, the person I saw train was this person. And this person's name is Alexander Gerst. And he is an astronaut, and he went on a 6-month mission to the International Space Station. If you press the next slide, to the International Space Station from here. He launched from here in a country called Kazakhstan, in a city called Baikonur, which is Russia's place where they launch all their astronauts. Because up until last summer, it was the only place we could launch astronauts to the International Space Station from. Now we can launch people from the Kennedy Space Center in America, but not then. So if you go to the next slide, and I got to go to Baikonur, launch to here, which is the International Space Station. I'm sure you've heard all about it today. If we go to the next slide, and in June 2018, this is my picture. I saw Alexander Gerst from the European Space Agency, Sergei Prokofiev from Roscosmos, the Russian Space Agency, and Serena Onion Chancellor, which you saw in the previous movie about women in space, from NASA, launched on the 6th of June 2018. If we go to the next slide, it was amazing. I want to show you my footage. So this is the rocket, the spacecraft. This is what all Roscosmos launches launch from, and they're in the very top part, just that conical bit there. And they're inside the rocket. They're in the spacecraft inside the rocket, and the rocket takes off, and suddenly within seconds you can't see them. So if you press the next button, if you press the next slide, this is it launching. I'd never seen a rocket launch before in my life. It happens so fast, you have no idea. I don't know if you can hear this or not, but it makes a kind of a rumbling sound. Initially, it kind of just stands there, like it's like holding back this force, and then the rockets flare up, and there's this kind of a pull of Earth, and then this push all the way up, and within about 10 seconds, you can't even see it anymore. It's just this blaze of light, and the ground shakes. You can feel the heats of the rocket. And I just didn't know what I was looking at. It was just so exciting. And I couldn't believe that there were 3 people on top of this extremely dangerous rocket. And it made me realize every time we put a human in space, it's extremely dangerous. It also made me really want to do it myself. Oh gosh, I really want to do that in my own lifetime. And then if we press the space bar again, I want to show you just one more video, because when Alexander goes up to the International Space Station, he's going to spend 6 months orbiting around Earth, as indeed our current ESA astronaut is, which is Thomas Pesquet, our French astronaut. And we have another astronaut going up on the 30th of October, Matthias Maurer. When they go up, they experience life as if they are floating, as if they don't have gravity acting on them. And that's because they're in a state of falling all the time. And I wanted to know what that was like. So I was very lucky, got to go to Star City in Moscow. If you press the next slide, please, in Moscow, we're trained for living in space. And it was a phenomenal experience. Now, it's called the vomit comet because it makes you feel quite ill, because the way it's a plane, I didn't go to space, it's a plane that basically forces you up at a really sharp angle and pushes you back on the ground, and the force comes down from your head. So if you want to feel what that's like, push down on your head, it'll make you feel ill. And then as the plane turns, we all go up for 30 or 40 seconds, and then the plane then goes really sharply down again, and then you feel this force acting down on your head again, which makes you feel vomity again. So go on, show the video there of how I experienced. We did it 10 times, and this was my experience. Thankfully, I didn't vomit, but loads of people around me did, because it really isn't easy on your body. So here we go. I brought like a picture with me, a young boy called Hayden made for me, and I had my Lottie doll with me. And the first time they tell you to hold on to the bar, and you don't have to hold on to the bar after that. I had bruises, so because you'll see that one there, it was a really kind of a jerky kind of maneuver, and I think I cracked a rib there. Now you'll see me holding onto the bar. You don't actually have to hold onto the bar, but in your head, because your body is confused, it doesn't know what's going on, and it keeps trying to kind of swim or all sorts of weird stuff. But the more I did it, the more my body started to adjust to it. But I kept holding onto the bar, and I didn't. And you'll see people behind me doing amazing things. But the force of gravity down on your head like that really does mess with your inner ear, so you feel seasick. And you'll see the guy beside me in this maneuver, which is the most scary one. He already has a sick bag in his right hand. You'll see that it's the arm that clasps. You see it? You see it? So he actually starts vomiting beside me. And that was only our second maneuver, because if you move too much when you're in zero gravity, if you move when they're pressing down on your head, you will start to vomit. And once you start to vomit, they push you to the front of the plane, and you don't actually get to come back. I was very lucky. I went really limp, and I think that's why I didn't vomit. So I think that's what I did right. So what I learned from experiences so far is that I'm not bad at being an astronaut. I still have an awful lot to learn, and I want to go up to space now as somebody who talks about space, like what I'm doing now. That's what I want to go up. I don't think I'm good enough to be an astronaut. Although, if I had maybe I would have been, but I'm happy now. I want to go up as this person that's going to share my stories and my videos and share them with what I want to do. And that's what I've been focused since 2014 for the last 7 years. So now let's look at some of the questions that came in. What does zero gravity feel like? It feels like learning to ride a bicycle and learning to swim, except there's no water. That's the best way to explain it, What advice would you give to some of the children watching today about how they can become an astronaut? Okay, there's 3 things. I would say keep learning loads of maths and science, learn how to do that. I would also say the 2 things that are the most important thing that you should learn about the people that get to be astronauts. They're good at learning and they're good at science, but actually they're really good people, and they learn how to take care of each other, and they learn how to share. If you have brothers and sisters, the best way to learn is be nice to your brothers and sisters, because when you grow up, they will be the characteristics that they're looking to view you, and when they run psychological tests on you. So learning, sharing, and caring, they are the three most important things about how to be an astronaut. Ali, I'm coming back. Do you want to ask me those questions, or will I?
I think that is really incredible advice, Niamh, because obviously normally it's the whole, stay in school, study this, study that, but it's also important to be a good human being as well on top of all of those different things, because I'm sure like astronauts always have to work in teams, I would imagine.
That's it. You have to be a good team member. And when I was on the Mars mission, that's the thing I learned, was like we were working in such close quarters. If somebody was selfish, it was like the energy changed really quickly. So astronauts are in this really confined space. So you always have to get along. And the only way you can get along is if you preempt, or you think in advance, what will my friend like? What will my brother need? What does my sister need? And if you're like that, you get along. And it's exactly the same in space. It's exactly the same.
Brilliant. We do have some questions that came in kind of off the back of that desert mission that you did. So we saw that you were growing plants using artificial light. If we were to start living on the moon, for example, would we need to use artificial light, or could we use the sunlight like we do on planet Earth, or how would that work?
I think that we could probably use the sunlight on planet Earth. We'd probably have to make a special kind of greenhouse. That would work. And and I think if you were, there's certain days of the year that might be darker than the rest, depending on how the moon is getting, that there might be days where we also have to grow them in artificial light, But that's a really good question. That is a really good question. Whoever asked that has a very good scientific mind. So I think that's brilliant.
Excellent. I want to ask kind of a gross question. Is that allowed?
Yeah.
What happened to the vomit in the Vomit Comet as everyone was flying around in zero gravity?
Well, you're given a sick bag, and you're told that when you vomit, you get pushed forward to the front of the plane. But there was one disgusting story, because everybody loves disgusting stories. One person forgot to tie the bag, so the next time we all went zero gravity, was up at the front. So all the other people that were spattered then with his vomit bag. Yeah.
So I guess he wasn't the most popular person on the flight then after that.
No, and smell, like it was all over and everything on the way out. It was disgusting.
Oh,
it's disgusting.
But
that's space, you see.
Yeah,
space. Like it's disgusting, because we take for granted. There's so many things we take for granted on Earth, Abby.
Absolutely, yeah. And actually, one of those things is our food. As you were saying, the food was a bit hit and miss. What was your least favorite of all the space foods you tried, and which was the most edible, shall we say?
The egg was disgusting. The egg was absolutely disgusting. Because you added, the only thing you could do is you could make scrambled eggs. So you'd put the powder on a frying pan, right? And then you'd add water. And you know the way like scrambled egg is like, it's like frozen. So even though at least if it's wet, it's nice, but this was like really rubbery. I really didn't like that. And what I liked the most was they had freeze-dried raspberries. So they were nice. So they were like raspberries with all the water removed. So they were nice. And the sausage was nice too. But no, the egg was disgusting. Absolutely disgusting. Disgusting.
So when we have those little freeze-dried berries in our granola, we're kind of eating like astronauts, is what you're saying?
We are exactly eating like astronauts. And also on the International Space Station, astronauts love, the wraps, the thing that you can get a wrap, the big round things. So they eat them because they don't have any crumbs. So they cover them in peanut butter. So if you have wraps at home and you spread peanut butter on them, space food.
Amazing. So we can all, as well as we were looking at making our own rockets and making our own landers, we can actually eat like an astronaut today as well, which is absolutely fantastic.
Yes.
Niamh, I have a question from myself, if you don't mind. We saw your footage there of the rocket launch. Was that scary to watch? I know you said it was amazing and it was really inspiring, but was it also kind of scary to be that close?
No, it's brilliant. No. It makes you really excited because there's this energy and the ground shakes and there's this noise, and it's like, I don't think you could hear the noise on that video, but it's like, and you see the rocket like shaking because the pull of gravity is pulling it towards the ground. And then you have the rockets going, no, I want to go. And Earth is going, no, you're not going. And the rocket's going, yes, I am. No, you're not. And then eventually the rockets go, I win. And it's like, it doesn't, you think when you see it on TV that it's straight. It's not. It's kind of moving in different directions at the same time. And then suddenly, it's just gone, Ali. It's just gone. And I wanted to like jump up and down and scream, but you're told, it's really bad luck to say anything until you get the clear message that it has safely, all the rockets have safely been deployed and they have safely made their way to the International Space Station. So that takes 8 minutes. So like I was like busting a gut for 8 minutes. And then they say it's safe. And I was like, yeah. So it's really exciting. Really, it's really exciting.
Are astronauts quite superstitious then in some ways? As you're saying with the launch, it's really bad luck.
Yeah, they have like every launch facility, they have their traditions. So in Baikonur, the tradition is that all the astronauts have to take a little wee on the tire of the bus before they go up. They have their last meal, which they photograph. And then in Florida, they have their own traditions as well. SpaceX have started their own traditions where they get the astronauts to sign the reusable rocket. So it's the astronauts at NASA, they play a game of poker before they go in. The commander has a game of poker with somebody from NASA there. You know, they're all so superstitious. Yeah.
And obviously these superstitions are as old as space travel themselves almost. That, you know, this is something that one person did so many years ago and everyone's like, well, that one worked, so we gotta just keep doing it exactly like that again and again.
Exactly. Yeah. In Baikonur, you see the rocket, the rocket gets rolled 2 days before everybody goes to see it. There's an Orthodox Christian priest on the railway line as it comes towards the launch pad that blesses it. The next crew up, they stand on the railway line to wave it off. All these things have to happen for a safe flight.
Incredible. And obviously you've had the amazing opportunity to see launches in real life, to meet some of these astronauts. Were there any astronauts in particular that inspired you, maybe as a child or maybe even now as an adult, that are particularly inspiring you to kind of explore space even further?
Yeah, there's 2 women and then there's a man. Yeon-yi, who you saw in your video, is the only South Korean astronaut, and she has just oodles of energy. And her story, she just applied and happened by chance. And Nicole is an artist, and she was, you know, she's also an astronaut, and she really understands the whole idea of wanting to be a communicator to go to space. Astronaut Robert Thirsk, who's a Canadian astronaut, he really understands the importance of how space can show us how to take better care of our planet. And that's a big part of why I really want to go to space, Ali. And it's very much in keeping with the message that you have of today, that astronauts, when they go to space, see this perspective of Earth and they see it as this fragile thing that's alive. And so I found that Robert Thirsk really. So I think anybody gone to space, I think, is inspiring, you know, and they're very brave people as well. And they're very selfless people. They really are. Yeah. So,
and it's great that you were able to highlight some women who've inspired you as well, because obviously it is Space Week and the theme of Space Week this year is women in space. So it's fantastic we're able to highlight some of the amazing work that women have done, both female astronauts and, you know, women who are working behind the scenes in control rooms and in design studios and working with engineers.
Everywhere.
So that's really fantastic.
And you know, I stood when I saw that launch, I stood beside Valentina Tereshkova.
No,
the
you
first
did not.
Ever in space. I did. I was like,
were you freaking out?
Which you're like, oh my God, was I what? Like, it's like, oh my God, it's the first woman in space. But she's like, don't look at her. Like, you know, you're given all these instructions. Don't approach Valentina. Don't look at her, because she's like, you know, she's absolutely, you know, the queen of space. And she's been to every launch in Baikonur. She's been to every single launch in Baikonur. She's about 83 now. She's amazing.
So if she's almost one of the superstitions now that she has to be present. She's got to be there now for every launch, pretty much.
Yeah. Oh, she's a formidable woman, I'll tell you. I tried to see if I could interview her, and they were like, nobody speaks to Valentina. No. because I was hoping I'd get an interview from her. Like, we don't speak to Valentina. I was like, okay, I'm not worthy. I'm not worthy. She's amazing.
Fantastic. I think we've got some great questions coming in of examples of sustainability in space, which seems like a great time to bring in Dr. Niall Smith, who is the head of Blackrock Castle Observatory and head of research at Cork Institute of Technology. So I understand that you guys are going to have quite an in-depth conversation about sustainable space. So Niall, thank you very much for joining us today.
You're very welcome, Ali, and lovely to see you, Niamh. I think I should
Niall.
And let Niamh and you chat away. I'm beginning to wonder. You know, this has been absolutely fascinating.
Your expertise is going to be key for this next segment. So I understand yourself and Niamh have known each other for quite a while. Am I correct in saying that?
Yes.
Oh, well, look, maybe about a year, because we're only 10 years old, you know. So obviously we don't know each other. No, we've known each other a long time. We've done a lot of things together. And it's always a great pleasure. And of course, Niamh was our artist in residence at Blackrock Castle Observatory for many years, and we hope to entice her back. But yeah, so it's been great. And, I've learned huge amounts from Niamh over the years, so and continue to do so. So that's always great fun.
And you know, Blackrock Castle has been a big part of me. You know, going from, you know, wanting to do something and thinking it was impossible to making it possible, because I became artist in residence at Blackrock Castle Observatory, Ali. It went from, like, I'd never met anybody in space or anything. I got to interview my very first astronaut, Dan Tanney, who is their patron, and they introduced me to all the people they knew at the European Space Agency. So a big part of me getting to where I am today is because Blackrock Castle to thank from that, and the whole team, you know. So any excuse, we're always working together, aren't we, Niall? Any excuse.
Always working together. Space is very big. It needs us all.
Exactly. Well, you know, that's another great thing. You know, it's all about the people you meet, and it's very important to talk to lots of different people, because you never know what one conversation is going to lead to further down the line for achieving your goals and achieving your dreams and all those sorts of amazing, wonderful things. And so I understand that you guys are going to leave us now on a conversation of, you know, really sustainable space travel, and you know, how achievable is that, how it can help us with space travel and also help us here on planet Earth. So again, if anybody has any questions they would like to ask, please do pop them in the chat. I'm going to step away and leave you guys to banter this one through. I'll be lurking in the background, so if you need me, just give me a shout. Okay, so I'm going to let you guys take it away.
Great.
Thanks, Ali. See you later. So Niall, like we've been talking about this a long time. So sustainability, I mean, it's as important space as it is on Earth. And I think there's loads we can learn from the whole space sector for Earth as well, can't we?
Yeah, and the space sector is changing a lot. So in fact, I might start in a minute or so with the slides as well, Niamh, and work through a couple of them. But the really thing about, we're at a really interesting point, and actually Ali mentioned it just at the end of your previous conversation, and you made it very clear that, you know, space is changing a lot, and we're seeing a lot more people like yourself and myself who, you know, maybe traditionally wouldn't have expected to be able to play a role, particularly maybe because we come from a small country like Ireland, but actually we can. And so I think one of the things that's really exciting, and the whole area of women in space as well, is that we're seeing more people and more women getting involved in space. So and then the question becomes, you know, why? Like, is it just for a bit of fun? Does it waste resources getting there? Does it do something that's really important to us? And I think the short answer is, of course, it does do stuff that's really important for us. But as we become more commonplace in space, we got to think about, how do we do that sustainably going into space as well? So, you know, I think that we're at that moment. I think this type of conversation is really important now. Probably less important 10 years ago, but it's really important now. So maybe I'll move on to the.
It's get easier, isn't it, Niall?
No, it is, and one of the things that maybe just to go through in the brief presentation that I'll do, to sort of to start us off with the conversation, Niamh, but feel free. For anyone at any stage to ask a question, or yourself as I go through the front end of our chat. I think it's really important that you know, we keep an eye on everything that we do now being sustainable, but not in a way that makes us worried. I think we have to be enthusiastic about sustainability. I think we have to think this is a challenge which is really exciting. Of course, there are always negative challenges about anything in life in a way, you know, making sure that everybody's healthy. But that doesn't stop us becoming doctors. Similarly, making space sustainable has challenges, but that shouldn't make us sort of walk away from it or be worried or think, oh, it's just for the super rich and so on. And maybe over the next few minutes, we maybe get some opportunity to chat to that. So maybe next slide, please. So one of the first things that I always think about to do with what space tells us, and just in general, I suppose it's just a general thing, is that the future isn't determined. And sometimes we think it is, others are doing it for us, but we can influence it. And I would say to everybody watching, you can influence it. And increasingly so, this is true in the space domain, because previously we were observers. We looked at it from a distance. You've already outlined in your talk how and your conversation, the whole lot, and it's much more than the talk, how we can become involved. So I think one of the things to say to people at the outset is look at how you can influence it. And we go to the next slide, please. So one of my favorite images, an image that you would know exactly, Niamh, is of course the famous the December 24th image of the moon. And if you just continue on with the next slide, but it's just actually one of the things, of course, it shows is there's no country boundaries. In fact, there's no boundaries at all on the planet. And of course, this image is iconic because it gets us to start to think about how the Earth itself is perceived by the universe. So if we think about the universe as this as we now know, this very large object, this very large thing, and when we look at the Earth, of course, the Earth to the universe looks really very small. And if we go to the next slide, we see a good example of that, which many of us will be familiar with. And if we move on again, just to see, it's the pale blue dot. So this, for those of you who are unfamiliar with the image, it was taken by the Voyager 1 spacecraft roughly at the distance of Saturn, when it was realized that if we turned the spacecraft backwards and pointed it kind of towards the sun, that the Earth should just about be visible. It would be the most distant image ever taken of the Earth, and it was taken by a hero. Well, the part of the whole process that went around it was a hero of mine, Carl Sagan. And when you look back, of course, the Earth just infinitesimally small. Yeah, Niamh, we talked so many times about Carl Sagan. That's another takeaway from today. If you haven't looked at Carl Sagan, any of his writings, go and look at some of them, I would say. But when we look back, it's this tiny pale blue dot. And one of the things that tells us, and why space is important, is if you go back to, say, 200 years ago, which isn't that far, and we can think 200 years is a long time, it's really not. We really have no idea that as far as we think, the Earth is at the center of the universe. So we're incredibly important in this universe. We're probably minded by various gods who are above this somehow glass ceiling or celestial sphere that surrounds us all. We're fundamentally important, and we're not really in control of our own destiny because that's determined elsewhere. But roll on 200 years, and we're absolutely not at the center of our universe. In fact, the sun isn't at the center of the universe. So we went through a period of thinking the sun was, and then we realized even the sun isn't at the center of our universe. And so we realized by looking into space from the Earth and going into space and looking farther out, because the atmosphere is great. We're all breathing the atmosphere, but it also is a nuisance when you want to look at things in really high detail. And also it stops you looking at certain things. For example, if you want to look at the X-rays coming from space, the atmosphere absorbs those. So you have to go above the atmosphere if you want to really understand the universe in which you live. But why that's all important in terms of our sustainability is it absolutely tells us, and again, not in a threatening way, but that, it tells us where we are in the universe. So if somebody comes to you and says, I have a solution to our sustainability issues, we're all going to live on that star. Well, we now know that that's not a smart thing to do, because apart from anything else, unless, the speed of light tells us how fast we can go in the universe. The nearest star would be 4.2 years to get to. With our current spacecraft, it would be about 200,000 years to get there. So just forget about it. You're not going to go to another star. You're here where we are. You've got Mars, you've got Venus, a couple of other planets, and actually they don't look like great locations. We might come back to that a little bit later. So space tells us fundamentally that we need to worry about the Earth, or need to care for the Earth from a sustainable perspective. I always like to kind of mention that to people, because somebody, I think, mentioned, Niamh, about what's the point of going to space, and does it matter, and should we spend money and all the rest, and should we not spend it elsewhere? But space has fundamentally changed how we understand our place and our sustainability. And maybe next slide, please.
Yeah. And you know what I think as well, I'll just jump in because I think it's related to what you're saying, is people forget that as our bodies have been completely created to live on this planet, like we have oxygen, light, and we have this gravity, and that's why we have bones, that's why we have muscles. We tend to kind of forget that we are such an integral part of the bigger picture of the planet. Like we are so integrated in it, and if we forget that, we're not going to take very good care of our amazing host, which is, of course, planet.
No, that's a really good point. Also, for the following reason, our planet looks the way it does because of life, but it doesn't have to look like this. So we have to be careful. It can look different, and it's still a planet. I mean, Mars looks different, Venus looks different, Jupiter looks different. They're happy out planets, let's say. So there's nothing absolute about where we are with the planet at the moment. It's a balance amongst many different type of balances that could exist on the planet. So if we want to maintain this particular balance, because as you say, it's helpful because we've evolved with this way, then we need to look after it. There is no problem with this planet changing. Absolutely none. The planet is happy to change. It's changed many times over its 4.5 billion year history. We're just that blink of an eye period in the history of the planet. It can change. So if we want it to be sustainable for the way we live, then that's actually up to us, not up to the planet. The planet can be sustainable in all sorts of different modes. The one that we need to really consider is the one that we have at the moment. So maybe next slide, please. Okay, and this actually is just, it's probably maybe a little bit actually hard to see, but just Carl Sagan, just a phrase, he said that we live on a hunk of rock and metal that circles a humdrum star that is one of 400 billion other stars that make up the Milky Way galaxy, which is one of billions of other galaxies which make up a universe, which may be one of a very large, perhaps infinite number of universes. And that is a perspective on human life and our culture that is well worth pondering. That's all about the idea of the scale and the need, and of course from Carl Sagan himself as well. So next slide, please. So, but I want to actually talk a little bit about money for a second. Oh, the horrible thing about money. Ultimately, if we're going to make space sustainable, Niamh, that we have to talk about, does it help with jobs? Does it help people to live lives? And how does that happen? So if you look at something like the European Investment Bank, who have no fundamental interest in space, they're not all, maybe there's some people in there enthusiastic about space, but mostly they're investment bankers and that's what they do. But by 2030, they say that space will be worth about 1.8 trillion euros. Now that's a huge amount of money. It's much bigger, for example, in the music industry. It's much bigger than the tourist industry of Europe. So it's an enormous global enterprise by 2030. And if you go to the next slide, or the so the way to look at it is to think of this 1.8 trillion enterprise as what we call space 4.0. It's moving from the old way of doing space to a new way of doing space, and to think of space no longer as rocket science. So one of the things, and I think you and me have found this, Niamh, is sometimes people can maybe get put off a little bit by thinking you have to be absolutely brilliant, or you also have to be interested in rocket to get involved in space.
That's right.
And we know, and I think yourself and Ali talked about this, there's so many people doing other things. So it's not rocket science. Anybody who's interested in sustainability, anybody who's interested in science, anybody who's interested in art, anybody who's interested in any domain that the human mind can get involved in, should consider that they have some connectivity with space. We like to think of it as solution science, and we like to think of it as democratization. So we have these wonderful 17 sustainable development goals. The objective of those, of course, is to try to make all our lives more sustainable and better, healthier, happier lives.
And
so
fairer.
And fairer, Niamh, absolutely.
Yeah.
So I wanted to just explore quickly a couple of ideas as to how space can help to achieve some of these sustainable development goals. So if we go to the next slide, please. So this is of many, by the way, of possibilities. This, because it's necessarily a snapshot. And if your issue that you want to solve isn't here, that doesn't mean, of course, that it's not even more important maybe than some of the things that we're going to discuss in the next couple of minutes. But suppose you've an interest in poverty. There's 800 million people, according to the World Health Organization, live in extreme poverty at the moment. So the question is, how might space solve that? So if we go to the next slide, there's an obvious way in the first instance by looking at how crops grow. So many of you will have seen images like this, but they're really important images because sometimes you kind of take them for granted. So this is an image taken by a European Sentinel satellite. You can see its fields. I think that's fairly clear. Where the image shows red, there's a lot of crop growth because crops that are growing emit heat. Where it's green or blue, there's less crop growth. And so you can see, for example, in the top right of the image that there's a very patchy field where there seems to be crop growth in part and not in others. So infrared imaging of crop growth allows us to decide how do we now go and make that field more productive, because it's there, and if we're growing crops in it and it's not being productive, then space allows us a very quick way of seeing how well our crops are growing. But if we go on to the next slide, then it maybe less obvious would be this idea of broadband and the idea of globally connected broadband and how that fits into the Sustainable Development Goals. Well, at the moment, there's roughly 3 billion people, not quite, but roughly a third a little more than a third of the people on the planet are not connected to the internet. Now, I think we've all become, used to in Ireland during the pandemic, but before that, just the critical nature of being able to talk to each other. Even this is a good example of this today. Here I am in a room in my house. You're in Strasbourg. We're just connected. It's the new way of talking to each other. We can share views very quickly. But we've all seen that all our students have maintained a considerable level of education during the pandemic by being able to connect by the internet. But for 3 billion people, they have no options. They're in villages, they're in small towns distributed in parts of the world, and there is no possibility of getting education through that means. So that's really a huge problem. And it's a huge problem because it actually affects women more than men. And on this, given that this, our images about women in space, women involved in space, then actually space affects or can help the women's side of things more than the men's side of things. Here's an example why. If you're in certain countries, women generally, because there's very little education and because they are often put lower down the opportunity scale for education, remain poorly educated, and therefore very often their options are very, very, very limited. So we don't want to, in Ireland, we don't want to say, for example, they should change their culture X, Y, and Z. But I always say, give other cultures options. Then let people decide within their own countries how they want to deal with them. Let that conversation take place. So, but at the moment, because of the broadband, we don't have that option for so many countries. So this is a real sustainable development goal issue, Niamh. You know, it's just enormous. So how do we solve it? Well, we can put fibers in, we can put things on the ground that, you know, masts that connect us together and so on, a bit like we do in Ireland. But there actually is a whole new way of doing this from space that I actually think it's like going from the steam engine to the combustion engine. I know combustion engines now are becoming not popular anymore because those. But the change between those two fuel the whole development of economy. So if we just go on to the next slide, and there's a little video which if we just look at the video playing. So the two blue circles are satellites connecting from, in this case, London through to New York. And around that you see these purple lines, and on the purple lines are white dots. So what we're doing here is we're using a signal coming up from London up to a number of satellites which connect with each other. And then now they've actually got to connect to the west coast of the US, to San Francisco. So this is what we called low Earth orbit satellite broadband. It already exists. Many of you will now know of it. When I started talking about this a couple of years ago, it was very much not theoretical, but there wasn't much going on. Now it's available. In fact, if you want to, there are a number of providers, one in particular, SpaceX, who will allow you to buy a device that allows you to connect using these low Earth orbit satellites. It doesn't make such an impact in Ireland, but it has the opportunity to make such an impact in Africa. And so I think one of the really exciting things that we're going to see in the next few years from a space sustainability perspective is we're going to bring education to rural areas in large continental regions that we simply couldn't have done 5 years ago. The technology wasn't there, and we simply can't do if we don't go into space. I think this is incredibly exciting. When we talk about how space can help us, this is one of the best ways we can do it. We see what happens when we connect people together. We see the opportunities that go down right into the homes of individuals. So for me, this is something that is an enormous step forward that you can't do. But you might think of it as space sustainability, but it actually, it is, because it educates us. And sustainability starts, in my view, with education, because how else do you know how to be sustainable if you can't share ideas about your sustainability? So maybe next slide.
Just before you do that, can I just throw a spanner in the works on that, though? It's an interesting time, though, Niall, where you have, these big mega constellations of satellites coming in. And I think we have to make sure everybody knows about it in order for us to make the right decisions about how this happens, because there is the other argument around these mega constellations that SpaceX is happening, is that I think it's going to affect how we look at the night sky. And what would you say to that? How do we, because I think that's also related to sustainability too, is like future planet to be and to look. And yes, we want satellites for communication, but we have to do it in a way that we all agree that we're happy with that.
So my background is I've been interested in astronomy since I was a kid, and I've loved looking at the night sky. But I do that with a full belly. I do that in a warm house. I do that by being able to watch my Netflix. I can go on holidays. I'm very rich because I live in Ireland. There are lots of parts of the world where, honestly, whether they can see the night sky very well or not is really not of interest to them whatsoever, because they're struggling to survive.
Okay.
So to me, of course, that doesn't mean that you just ignore astronomers and so on. But the obvious solution to me that needs to be worked on, Niamh, is let's look at how we bring in technologies to make those satellites significantly less reflective. You see, we haven't needed to worry about that up till now, because a couple here, a couple there. Actually, it's been fun to watch the odd little piece of light go across the sky, and mostly it doesn't influence your observations. Of course, this now challenges that. So my kind of thinking is, well, then let's get somebody in Ireland or something to make a material that's super black. But there's some challenges around it for reasons that we could discuss maybe else at another time. And there are challenges, but there's challenges making electric cars. There's challenges making the rocket you saw take off on Baikonur. If we just put this stuff here together, we'll figure out how to make satellites black. So to me, this is an interim problem. I can't prove that, but let's do that. So let's use our smartness. We talk about Ireland being a centre for smart manufacturing, for materials. Well, great. I think it is. So why not an Irish solution that makes satellites darker? That would be a wonderful way of doing the two things. So I completely agree with you, but I always get concerned about.
I know.
I think of doing charities in life, and for me, I want to see us help. And I don't mean as if people who want to look at the skies are nasty people. I want to do that too, but. So I am always very careful trying to say it in a way which doesn't sound like, No,
I get it. But it is that thing, and I think you talking about it today raises awareness, and by raising awareness, we can make the right decisions going forward. And the more people that know, the better chance we have of doing the first time around. So sorry, I just jumped in there. I'm just curious.
One of the things, no. I think it's a really great question, and I have struggled with the answer in one sense, but then I've just become more. I just think we have to look after people first and foremost.
We do first, people first, definitely.
Yeah, and so to do that, then let's solve the other bits of the problem, because the other bits of the problem are important. But they're if we're talking about a sustainable world, what does that mean? It means that the animals, the plants, and the people that live on it can have a reasonable expectation of a reasonable life expectancy. So anything that we do, that we can do, that knowingly doesn't help that, I that challenges me as a species on this planet. And look, in 100 years, let's even suppose the following, and I know we've maybe talked about this bit a bit longer, but let's suppose we have to put a pause on having the night sky beautiful for 100 years until we have everything else sorted, and then we have these new super dark satellites, and we look back in our history and we say, there was a short period when the night sky was ablaze with lights, but we got over it and now we're back again. Like, we've had things in history where things have come and gone, and where not everything has been ideal. But the sustainability argument is just a critical one at the moment, and getting more people involved in it is a critical. And we've talked about this a bit before, and I know that's your ethos through and through, Niamh, as well. I know you're asking the question because it's good to ask the question, but I also know that you want to see people dealt with really well. So I know there's a couple of questions coming in. Maybe we'll just run to the end of the presentation, and then we'll take some of the questions that are coming in. Might be the best if that works for everyone. So just in terms of other things like clean water, well, this is an example from, again, a European satellite showing it's September of last year. Brown is where there was little water, and blue is where there's sort of a reasonable amount in relation to what you'd expect. No surprise, Ireland continues to be blue. Someday we might turn around.
Well, we're lucky. But we're lucky, I think that's a great thing. We're very lucky. Yeah.
We are. No, we absolutely are. And we've seen that even worse this year, the way that's happening. But if we move on to the next slide, what might be a little bit more surprising is we can actually look at subsurface water. So we can look at places where there's evidence from the Earth, from space, of subsurface water. And why that's important is that very often we have communities who live in harsh environments, and they live on the banks of rivers, but actually close by there's subsurface water which maybe they're not aware of, that they could use to improve their living conditions. Now, you can't keep on, the Earth is we talked about before, the Earth is a fixed thing, so it's a closed system. So you can't just keep on taking from everywhere and not returning it. But if we treat our subsurface water carefully, then it's another source of water which we may not actually be aware of in communities, and that might help again to make those communities more sustainable and give them a healthier and less difficult lifestyle. So next slide, please. If you talked, actually, Niamh, fascinating about going up, of course, as astronauts. If we kind of go to the other end of the scheme, which is the purely autonomous vehicles. So we're seeing a lot of these CubeSat type devices, or even smaller. And there's a picture here in the middle of a CubeSat, which is 10 centimeters by 10 centimeters by 10 centimeters. And these are being put up a lot by private companies, by universities. We have one in being built in Ireland at the moment, and these are the idea is to launch these to do tasks which would have taken a car-sized object in the past. And actually, this goes back to a bit of the conversation you were asking earlier, like those big satellites that Starlink is using. Well, maybe we can also shrink those down. So it's a bit like our mobile phone, this device. Incredible what we can put inside that. So
amazing.
When we think about satellites, we make them smaller now. And actually, if we go on to the next slide, the smaller satellites, they're cheaper to build. They're more environmentally to build and fly. Because, when you put a person in space, that's 80 kilograms or 50 kilograms or something like that. And, we can't really shave that down too much because
it's not possible.
A person is a person. But we can try to shape satellites and make them smaller and smaller. The less mass you put in space, the less fuel you use, and that's good for resources. The less energy you use, that's good. And the more you can fit then into maybe a given rocket launch. You can also use other types of rocket launches, actually, different to the ones that you were showing from Baikonur. So, and new materials mean we can have less effect on the atmosphere when they re-enter. And if you go to the next slide, a really interesting case of a Finnish group who are going to launch a wooden CubeSat.
That's brilliant.
Now, obviously, the electronics inside it can't be all wooden, but they're looking at how they make the infrastructure wooden, and they need to find some things about it. But so if you can make it from sustainable materials that are light, but also then are non-toxic, in this case, it's birch plywood. But I suppose the key thing is, let's just think outside the box. Let's make the satellites smaller. Let's get people thinking how they might do that. Yeah, so people on this call might be thinking, I've got an idea how I could do this. How we do this better. And that's what Space 4.0 really is all about. If we go to the next slide, just to give us time to take the question. Sorry,
of course, a wooden CubeSat integrate quite naturally if, when it comes to its end of life, if it just sort of slows down and then gets pulled towards Earth as it comes to its end of life, that would be a material that would just easily break down. That's really smart, really smart.
Yeah. Yeah, and I think it's back to that really think outside the box type of thing. And I just want to say, in terms of the outside the box, so we've started or parted in Blackrock and in Munster Technology University, part of what's called the School Small Satellite Project. And so what we've started at is to gather ideas from schools with the ultimate objective in 2023 to launch a small satellite that has been partly designed by schools from around the world. That's and by partly design, that's really about what's the problem. So yeah, and the idea here, Niamh, is to get people thinking, get them involved, get their ideas, and really capture those and make people realize that space is no longer solely about looking on. By the way, I love looking on. Don't get me wrong; it's lovely to watch all of this stuff because it's just great. But also then, on another level, become involved. So if we just go on to the next piece on this slide, we want schools to consider what's important to them in their locality. We go on to the next piece. Then the idea is that we will take those ideas and co-design the satellite to address some of the issues. We go on to the next piece. Part of the ethos of this is that we use components that are already off the shelf, not ones that are going to be very expensive. So we're really trying to keep the cost of this down. And also, if they're already off the shelf, then we don't have to make them specially. And so they already have used up their energy, all of that type of thing. And then the idea is that satellite will be available either through a downlink when it comes over your school, depending that requires certain technology to be installed at your school, or via the web. So it's kind of a series of linked chains that when we come together, we'll have look, I'm not big into the world's first or this first or something, because you never know who's doing what. But I suppose we're trying to make sure that we get as many people involved in this as possible, Niamh. So more on this anon, so to speak. But this becomes possible, and building satellites and get kids thinking about sustainability, and teachers thinking about sustainability, and companies and adults thinking about sustainability. This isn't targeted at any particular demographic or age group or whatever. We want everybody to be thinking about the options that space has. Next slide, please. I think there's a talk on space debris coming up. So just one of the things about space debris, we just have to be careful. It was going back to what you said, Niamh, about all these satellites we're sending up. So I think we do have to be very careful as well that we don't do this in an uncontrolled way, because that's actually really bad from a sustainability perspective. It was on earlier. Sorry, I missed that. Apologies. So there would have been a lot of talk on about the
space
about
debris.
Space debris. Yeah. So it's a potentially big problem if we don't do something. With it. So next slide, please. And obviously our climate, this is maybe just coming towards the end of my presentation, but if you want to understand the climate, space is a brilliant way for doing this. If we go on to the next slide, we've all really at this point seen this, but space gives us this global perspective. But one thing I want to say here on it is really this. When we look, and probably there's few enough skeptics now, which is great, and I think the science, I hope, is accepted by most people. But one of the things point I wanted to make about the type of images that you see from these satellites, you have different satellites launched by different countries using different technologies, analyzed in different ways, and then aggregated. And this is one of the strengths of science. So if I come and I launch my satellite and say Ireland is constantly at 30 degrees centigrade according to my satellite, others come along and say, well, in our satellite, that's not the case. And so these type of images that we see there's a whole series of checks go in them before they get accepted as the actuality of what's happening to the planet. And I think that's important, because you could otherwise assume that the space industry is this monolithic industry that all talks together, all agrees, and pushes out the same stuff. And it's very much not. So people are all the time looking for new ways to get the data. But within the variability in the data, it's very clear that the climate has changed. And space is allowing us to hone the models and
monitor that.
Yeah, which is really important. And one of the things that it's allowing us to do more regularly is it's on a finer time scale. So previously we got these sort of these maps of the whole globe, like we're showing here, and that's fine. But like, to get a map of what's going on in Ireland would happen only every few days or every few weeks. Now we're seeing granular activity, what's going on in Cork, for example, every couple of days. So we're really starting to be able to hone these models and put in a lot more data. So that's exciting for the future, because when we know things, then at least we know the thing, and then we can decide on how we react, or otherwise then it becomes maybe political or something like that. Next slide, please.
Yeah.
This by the way, and if you just go on to the next, one of the things that some of us have been talking about is the idea of a 18th Sustainable Development Goal, which is the space economy, which supports all the other existing Sustainable Development Goals. That's one of the things I was trying to kind of point out in this talk, is that space isn't an end in itself. And I know I focus more on looking back sustainability, how it affects us on this planet, but just in the last 2 slides, if we may move on to the next one. Oh, actually, I've forgotten that there was 3 slides maybe, but this is my friend Carl Sagan again.
Carl.
So,
Mine too.
Good old Carl. Since in the long run, every planetary civilization will be endangered by impacts from space, every surviving civilization is obliged to become spacefaring, not because of exploratory or romantic zeal, but for the most practical reason and manageable: staying alive. If our long-term survival is at stake, we have a basic responsibility to our species to venture to other worlds. Now, Sagan is talking about long time scales here, but eventually, no matter how much we take care of our planet, our sun finishes. In fact, before it finishes, it expands and fries us all to a crisp. So at some point, we're going to need to move off this planet. The other thing is that if for example, we decide that there is no cap on the number of people that we think our species should have, well, there is a finite amount of people that you can run off a planet of any given size. So if we want to allow more people to be in existence, then eventually we need to move off this planet. We're just so that everybody's clear, the sun isn't going to do anything really interesting in a negative sense for another 4.5 to 5 billion years. So this type of commentary is a very long term. But nevertheless, one of the essence of it is we need to understand how to live elsewhere in this universe. Because wonderful and all as our planet is, gosh, wouldn't it be lovely to see if there are other planets that we could coexist with and potentially inhabit. So next slide, please.
It'd be amazing.
So our first step, and Niamh, you would know this well, it's back to the moon. There's a lot of effort now going to the moon. There's a lot of talk of Mars, but I think the real first advantages are going to be by going back to the moon. And that's going to be exciting. But the way we're going back to the moon is really different to the way we did the last time. It's with a sustainability hat on, which is great. And the final slide, because I think there was some questions, and I'd really like to get a chance to go to some of the questions. The final slide, I kind of overtalked things. There's a surprise, Niamh. You've never heard me talk too much before. But space now it provides us a vast array of opportunities to support sustainable development. It can help us to improve the lives of people on Earth now and secure our distant future. So this is why space is just such an exciting but also important element of now what we do on this planet. So I'm going to leave it there for the minute, Niamh, and maybe there's some questions and so on, or you just might want to disagree.
I'm looking at them here.
Yeah,
I'm gonna jump in and ask you this question here. So this question here says, what do you think is the best sustainable lesson we can learn about space? I think that's a no.
Yeah,
What's the best sustainable lesson we can learn about space?
Yeah, so I think the thing, the first, the most sustainable lesson, I think, is that our planet has an absolute closed loop system, and we can see from space that it's effectively impossible on any reasonable timescales to change that. So we talk about mining here and mining there and so forth, but on any of the timescales that we're concerned about to do with climate change, what space tells us is we've got to think of the planet as a purely closed system. In the distant future, we can make it a more open system. Maybe we'll be traveling between planets. But right now, and for the foreseeable future, it's not. And I think we need to be very careful about commentaries that say, we just move lots of people to Mars or something like that. Completely unproven. And do we have the ethical right to do that as well? Like there's an awful lot of questions. We have this planet. We've made it, through evolution and so on. So I think we can reasonably argue that ethically we can try to look after it. But we've all sorts of other questions about going elsewhere, and even going back to the moon, we have to be careful about how we do that and just sort of decide we can take over. So I think that the main thing is, we're closed loop, and nobody or nothing is going to change that in any reasonable time scale. So that's scary, but equally you make progress by being scared and then doing something else as a result. I don't know why I said scared.
Yeah, it's interesting to to bring in those United Nations Sustainable Development. It's great that we're now thinking of them from the perspective of space. So so that was really great, Niall. Thanks. Ali, I'm going to pass back to you.
Brilliant. Yeah, we could just have a few more questions come in that we're going to race through super duper quickly because we're technically out of time, but this is too good not to continue with it, to be perfectly honest. So we're rattling over for a few extra minutes. So a few questions in the chat. Julie was asking, and made the great point that rocket launches emit huge amounts of CO2, which is obviously one of our greenhouse gases contributing to climate change. What kind of advances are going into that to make launches themselves more sustainable and to have them produce less of those harmful emissions?
Yeah, well, actually, one of the things that I thought didn't get as much press as you might have had recently, when Richard Branson took his rocket into orbit, and then a week later, Jeff Bezos went up, and then obviously you got the SpaceX guys. Actually, Amazon, because Jeff Bezos was the owner of Amazon. I think he actually resigned recently. But anyway, but their rocket actually is a hydrogen fuel, so they don't actually generate CO2. So they've said we're going to do this in a sustainable way. So there's actually the cleanest rockets that we have at the moment, and I think that's been kind of very much under the radar. So there are also sorry, Niamh, you might want to.
No, I agree with you. I think it really wasn't brought about. But I think, again, it's this thing of, and this is why events like today are really important. I think there's just so much going on in space. It's hard sometimes to keep up to speed with it. So it's days like today that help people understand that, these moments. So well brought up, Niall.
I think another great point on that is the kind of, as well as looking at alternative fuel sources, this move towards reusable rockets. Once they stick that landing, and theoretically we can get rockets that can be reused, again, that will be a huge leap towards the whole idea of sustainable space travel as well. A few more questions that came in. Obviously, satellites can sit kind of at different levels within Earth's atmosphere. How far away from our surface would those satellites actually be sitting?
Yeah, so you roughly the low Earth orbit satellites go from roughly 500 to 2,000 kilometers is the one. So 500 kilometers is just a little bit above the International Space Station. It's really quite low down, and then 2,000 kilometers. So if you're at 500 kilometers, there's an advantage in that it's easier to get to 500 kilometers than it is higher. So you use less fuel. But you actually get dragged by the Earth's atmosphere just a little bit at 500 kilometers. So if you want to stay up for a long period of time, you go up to 2,000 kilometers. But here's the thing, Ali. If you're at 500 kilometers, when I showed the video of communicating using low Earth orbit satellites, well, the lower they are, the faster you can make that connectivity. And actually, Ireland, if we decided in the morning to launch 2 satellites, we could have the fastest connectivity between Europe and America using satellites. We'll outperform fiber, by about 50%.
Wow.
And so by having low satellites, you can communicate around the planet much quicker than you can with higher ones. And for some application, that's going to be important, for others not. But anyway, between 500 and 2,000.
And while we're talking the realm of satellites, you were talking there earlier about, you know, CubeSats and small satellites that can be made. And I know ESA have the CanSat program for school-going kids as well. Can anyone launch a satellite? Do you need permission? Do you have to register it? What's to stop me going out? Well, apart from my lack of knowledge on how satellites work, what's to stop me going out there and just deciding I'm going to launch a satellite today?
Yeah, well, so you do need a license to launch, but it's actually very vague depending on what country you're at. So depending on where you want to go, there's lots of people will launch for you, and that's become very easy. So if you want to get a satellite launched, and you have, and depending on the size satellite, it might be sort of like 50,000, it might be a bit less, it might be a bit more. It's not millions. Now, I know 50,000 is a lot, but I don't have it. I would have put up my own satellite at this stage. So you can't do it from Ireland, for example, at the moment. You're not allowed to launch from Ireland. And one of the reasons why there would be an issue there very quickly is that if you launch from a jurisdiction, there's the danger that there's associated with that a responsibility if anything goes wrong. So suppose you launch from Ireland and it lands on London, that could be really bad. Would be clearly not good anyway. So people are very concerned about the insurance side of things. So at the moment, there's very few places that actually you can launch from legally.
Yeah, one of those insurance risks always getting in the way of everything these days.
And it's incredible how many launches there are now regularly. Like if you go onto any of the websites, any of the websites around the United Nations and their space law websites, they do try to list every single launch. It's reams long. There are so many satellites now being deployed on a regular basis. It's incredible. I don't know how they keep up with them. So.
And actually, Niamh, the interestingly, Ireland is a really good place to launch satellites from a physics.
That's right, because of where we are.
Where we are. So, and actually, you might have seen that the Shetlands is going to have. Well, we should. We absolutely should. I mean, Anyway, that I'm sure we get a lot of people very exercised. But just from a purely physics perspective, we're in a really good place to launch from. I mean, we have the sea. Which means there's low population density. If we launch over that, something goes wrong, and most satellites are pretty small. So honestly, if something did happen, it doesn't massively affect the ecosystem in the region. But you don't want to be landing in a city or something like that.
Yeah,
too. That's a different.
Of course. So on that, like Ireland is apparent as from a physical point of view, a very good place to launch from. Obviously, Ireland, as Marie has said in the chat here, Ireland is a big producer of tech, which goes all around the world. So, should we be pioneering the push for sustainable space tech? Are we in a position? Are we a bit too big for our boots? Are we actually in that position where we could be pioneers of a more sustainable space travel?
Yeah. So you mentioned earlier, Ali, about all the people sort of in the background when Niamh was talking about the astronauts and so on. So the space industry is actually thousands of people, and then a couple of people that we all know or hear about. But most of the companies that you're never going to hear about, and that 1.8 trillion that I mentioned is really not going to be about. On the astronaut side, it's going to be more on other sides, the telecom side things. So Marie is exactly correct. If we simply harness companies who are really good at what they do now, and they pivot and say, well, actually, let's go back to the thing about black. We make black materials, let's say, I don't know, for the underside of cars, for example. I have no idea. And so maybe that would be good in space. So the key thing now, I'd love to see Ireland. We've talked about this a bit before, Ali, about Ireland, the center or the hub of sustainable space technology. Yeah. And attract companies to this country. It's been done elsewhere. Luxembourg has attracted companies who are interested in space mining. We could make a decision to attract companies who are interested in sustainable space development. Now, what that means is you give them certain tax breaks or other things. I get that. But we could make a very proactive decision to do that. And it would send out a fantastic signal to the world about what Ireland thinks. But also, critically, it will help, I think, to attract more investment into the country. I think there's evidence for that, you know, in other domains, and I think also it will make sure that we can grow the space economy in a sustainable way. So I think it's a really good point. And I think it's something that should be done, and I think we should continue that conversation.
Yeah. And as you say, obviously investment opportunities, but also education opportunities. You know, if the industry is here based in Ireland, it gives more scope for people to study these fields and know that they can stay at home if they're home birds and, you know, contribute to the industry at the same time because the infrastructure will be there. We are going to have to wrap this up, guys. I think that was a really, really interesting conversation. It was lovely to kind of look at the idea of space sustainability and, you know, how space travel can, you know, help us solve sustainability issues on Earth, as well as getting to space more sustainably, but looking at our issues. I think it was lovely to see all those satellite images that you were showing, because there's that lovely quote that says, human eyes can't track change, but photographs can. And that's obviously what's a huge tool in looking at our planet and looking at how our planet's changing and what we can do to kind of help that out. So again, Niamh and Niall, thank you so much for joining us as part of our Sustainable Space event. For those tuning in, we're going to take a quick 5-minute break. And when we come back at 3 o'clock, we'll have Dr. Peter Gallagher and Anya Flood from Dunsink Observatory and ILOFAR, who are going to talk to us a little bit more about the future of what it is that we can do. So again, Niamh and Niall, thank you very, very much. And we'll see everybody again in 5 minutes time. Thanks very much, everybody. Thanks, guys.
Hi.
Okay, welcome back everybody yet again. We're delighted now to be joined by Dr. Peter Gallagher, who is Head of Astrophysics at Dublin Institute for Advanced Studies, and Anya Flood, who is the Education and Public Engagement Manager at ILOFAR at TCD. Hello to you both. How are we today?
Hi, very good. Nice to be here.
We're absolutely delighted to have you on board. So the title of your segment here is Making Space Sustainable, What Can We Do? So we need to look a little bit at what's kind of been done up until now, how that's worked and how it hasn't worked maybe, and kind of what we can look towards in the future a little bit. Now, Peter, I have to admit, I was reading your bio a little bit just before the start of the talk here. You worked for NASA.
Well, I still do, but I was an employee of NASA for 3 years. I worked at NASA Goddard Space Flight Center for 3 years, but and then came back to Ireland and then started working with the European Space Agency as well. But yeah, I collected a lot of NASA T-shirts along the way.
I was going to say a few ID badges just to have the logo on them and as much NASA.
Well, it's funny. They with the ID badges, everybody wants them, but you're not allowed to take them. You have to give your ID, but it's a major problem for them that people keep on trying to take home the ID badges, but you're not allowed, so you have to give them all back. Unfortunately,
it's a nightmare if every ex-employee is walking around, no matter how long they've worked there, they've still got access here, there, and everywhere. So
yeah, but it's funny, when I did work there, you'd go out to the coffee shop, or you go out, you'd always wear your NASA badge because it's just cool.
Show off your swag.
It's just ridiculous. It's ridiculous.
Obviously, we can't talk. Maybe we'll talk afterwards about some of the. We can't say it here live, but some of the cool things you may or may not have taken from the centre.
Yes, yeah. Okay.
Okay, guys. So again, if anybody has any questions for Peter or Anya, again, please do pop them in the chat. I'll pop into you guys again at the end and feed some of the questions through for you. But apart from that, I might leave you to rock and roll if that sounds good to you.
Sounds
brilliant.
Good.
Perfect. Cool. I'll let you take it away.
Thanks so much, Ali. So yeah, thanks everyone for having us. Thanks to the Rediscovery Centre for organising this brilliant day-long event with lots of different people participating. But Peter, to start off, do you want to just give us a bit of background to, obviously Ali said you've worked with NASA, but where you work now, what you do, and kind of why we're here talking about all of this?
Yeah, okay. Well, I guess to give you a background, so I work for the Dublin Institute for Advanced Studies, which is a research institute in Dublin. We have about 120 people who work on theoretical physics, we work on geophysics, we work on astrophysics, and we also work on Celtic studies, believe it or not. But we're based in the city centre in Merrion Square and Fitzwilliam Place and Burlington Road. But we also have an observatory, Dunsink Observatory in Dublin 15, and that's where I spend most of my time. The institute was founded by Eamon de Valera in the 1940s, and the first kind of wave of people to come and work were some of the people trying to get away from Nazi Germany and the war in mainland Europe. And Erwin Schrödinger then was one of our first employees. So he came from Austria, and he was the first director of theoretical physics. And it was just amazing that we had somebody of the kind, like of the ilk of Erwin Schrödinger at the institute. And he was working on the quantum mechanics. He was one of the originators. He actually wrote a letter to Albert Einstein asking Einstein to come to Dublin, and Einstein was really happy in America, so Einstein declined, unfortunately. So to have if we'd had Einstein and Schrödinger, that would have been just absolutely incredible. But that didn't happen. But nowadays we still do theoretical physics, and they work on like quite abstract concepts about forces and particles, and like the fundamental nature of the universe is what they work on, and they use mathematics to do that. Our geophysicists are interested in volcanoes, they're interested in earthquakes, and they're interested in how the Earth behaves as part of our, our universe, really. Though it's about understanding what's below our feet and what's above our heads as well. And then I'm head of astrophysics, and we have about 40 people working in astrophysics. We work on lots of different aspects of it. We have people who work on star formation. So there's a group under Professor Tom Ray, and his group are looking at gas clouds with large, huge telescopes in the Canary Islands and also in Chile. And he also uses spacecraft as well to make his observations. And I'll come back to that in a second. But he's interested in, you've got a gas cloud in space and it begins to kind of spin and then it begins to collapse and you form a star. And you also form, like there's a disk of material around the star. And then also you can get planets forming. So he's interested in how stars and planets form. And as that's happening, there's a jet of material that comes out of it. And he's also interested in these jets. So he's really interested in the birth of stars. Then we have other researchers who are working on planets. Katrina Jackman is a very close colleague of mine. Her field kind of overlaps with mine. But she's recently joined us, and what she does is she's interested in magnetic fields around planets, and particularly around the gas giants, so which are planets like Jupiter and Saturn. And they have enormous big magnetic fields that sit around them like a big bar magnet. And the thing is that these magnetic fields are really important to protecting a planet from the wind from the sun, which can have interesting effects. If you're Mercury and you've got all these particles coming off the sun, and you've got no magnetic field, that's not a good place to be. So, it really comes down to a question of life and what makes a planet habitable. Our little rocky planet is not as close to the sun as Mercury is, and it's not as far away as Jupiter and Saturn is. It's kind of at a sweet spot, which is called the Goldilocks zone. And it's just not too hot and it's not too cold. But also we have this lovely magnetic field around us that protects us. So that's what Katrina Jackman studies, and also my research group also studies the sun and the activity on the sun, but also how it affects our planet, how it affects our atmosphere, how it affects our magnetic field. Now, I mentioned how we do this, and this gets to the whole concept of sustainability. How do we do sustainable science? Well, the first thing is, we can build big telescopes. So we've a large telescope in Dunsink that people can come and look at, but it's not research quality. It was in the 1800s. But nowadays, we've got to go to the top of a mountain. Usually you've got to cut a little bit off the top of the mountain, and then you've got to build a telescope on the top of it. And these telescopes are kind of the size of, several Liberty Halls. These are not small things. They might be, 50 meters across and 100 meters high. These are enormous objects, and they don't cost, 100 grand. They cost a few $100 million to $1 billion to build one of these things. And so there's the financial cost that is something that you really have to look at as, should human beings, should taxpayers be funding these kind of things when we have other things that are needed, like housing, like transport, like schooling, like education? And that's a serious question that we as a society have to ask about this kind of work. The other thing that may be even more pertinent to the conversation today is around rockets. So we use rockets to get satellites up into space. And the problem with ground-based telescopes is that the atmosphere blocks off a lot of the kind of light that we want to look at coming from stars. So, our eyes can look up and see optical light. But if we want to look at a star in X-ray light or gamma ray light or radio light, then if we're looking at any of those, well, the atmosphere absorbs a lot of those ones that I've mentioned. So in order to look at gamma rays or X-rays, we've got to get a satellite with a telescope on it above our atmosphere. And to do that, we've got to use a rocket to go through the atmosphere. And that has its own pros and cons. Number one, it's 100 to 200 million per launch. That's how much it costs to do a launch. But then when you're doing the launch, you've got solid rocket boosters. Usually you can have a liquid propellant as well. And they all have their own impacts. And we can talk about that, I think, later on Anya. But in a nutshell, we as scientists are curious about trying to understand how the sun works, how the stars work, how the planets work. And we do that in the city centre and in Dublin 15 in Dunsink.
And actually, Peter, another thing that you're also involved in, of course, is ILOFAR, which is a radio telescope in the Midlands.
Absolutely. Yeah. So the past decade of my life really has been around building a radio telescope in Birr Castle in County Offaly. And it's a strange looking thing, but it's basically a load of wires and antennas stretched off across about 2 football fields. It doesn't really look like a telescope, but what it does is radio waves come in, and there's these wires, they're just wires like that, and these wires take in radio waves, and the radio waves come in, hit the wire, cause electrons to move in the wire, and then we have an amplifier at the top of it, and the amplifier then takes a weak signal and converts it into a strong signal. And then we send all those data together to the Netherlands, to a supercomputing center, and it's collecting radio signals from all around Europe, from 52 different LOFAR stations around Europe, and then we make radio wave pictures of objects in space. And it's the biggest telescope, the biggest low-frequency radio telescope in the world. It stretches from Poland and Latvia right across to Ireland, so it's nearly 2,000 kilometers wide. And we're delighted that Irish astronomers now have access to that. There's actually a sustainable thing there as well. Excuse me, that's interesting. Because we use supercomputers and we generate so much data, we have to use supercomputers to process the data. And if you have supercomputers, they get hot and you've got to cool them. And that's a major issue for us. There's a future telescope called a Square Kilometre Array, which is €1 billion spacecraft telescope. And they really are making a huge effort to look at green supercomputing. How can we process data? How can we store data? Because ultimately they go into data centers, and we all know that data centers have a significant carbon footprint. They use a lot of electricity, and they in order to be cooled and in order to run the computers. So these are important questions as well. So it's not just space travel that has a sustainability aspect. There's also ground-based telescopes with the computing needs. And actually that makes me think as well, the teams are always international, no matter what. So you'll have hundreds of scientists and engineers working on these, and students as well. And so they have to meet each other. So generally, there's a lot of people flying for these. And so if you are flying, you might have, before COVID, I would have flown at least once a month. And I'm one of hundreds who are flying once a month. If you're working in a European project with the European Space Agency, that's fine. It's Ryanair to Brussels and back. But, if you're working with a NASA mission, then it's to Washington, D.C. 5 times a year. So, there is a carbon footprint just to get the scientists and engineers together, which is an important thing to consider. And people have made calculations of what the CO2 is for all that travel and how we can reduce it as well. And more of my colleagues are either not traveling and doing it on Zoom, using boats, trains, bikes, whatever way it is, rather than hopping on the plane.
And it's great that these things are being considered both on an individual level, and as you mentioned, with things like the Square Kilometre Array, with trying to not just looking at sustainability of spacecraft and the obvious things like the rockets are obviously emit a lot of CO2, but things like the supercomputers and cooling them and trying to conserve energy and be more efficient that way. So it's great that these things are being considered. What we really want to do, obviously, we're going to chat to Peter, get his opinion and insight on a lot of these things, but we really want to find out what everybody else watching thinks as well. And actually, we've got a couple of questions, Peter. Charlie Black was wondering, do any planets not have magnetic fields?
Yeah, there are, in order to have a magnetic field, you have to, this is a long story. I teach this in 4th year astrophysics. I teach a course on planets, and we do a whole lecture on magnetic fields. But how do I say? There's a couple of ways. Number one, you have to spin. So that's one thing. If you're spinning, you that's half the battle. The second thing is you need charge. You got to move charge to generate a magnetic field. So if you're Jupiter or Saturn, inside it you've got liquid hydrogen, and the liquid hydrogen acts like a metal, and it's really conductive. It's like a superconducting liquid, and it's rotating. That generates a magnetic field. On our planet, when our planet was formed, it was just a molten blob of rock and metal mainly. But as it cooled over time, the heavy stuff went to the bottom, and the heavy stuff was iron and nickel. and it remained molten. It's still molten today, 4.5 billion years after it was formed. And as it's rotating, that molten metal stuff in there is your charge. That's your current. And as it rotates, it generates a magnetic field. But if you then go to let's go to Mars. Mars is much smaller than our planet. And it would have solidified. It's solid. It doesn't have any liquid in there. So it really doesn't have much magnetic field. It has little pockets of magnetic fields around the surface. But, you know, the reason it's red is because there's iron oxide. The iron didn't get a chance to go into the center. It's kind of all over the place. And so it doesn't have a magnetic field. Well, it has a very small, weird magnetic field, not a big one like ours.
For the intents and purposes of protecting it from radiation, it's as if it doesn't have one.
Yeah, well, if you do want to go to Mars, I mean, the first thing to do is, and you know, who wouldn't want to go to
Make
Mars?
Make friends with somebody who has a spaceship.
Well, yeah, that can be done. You know, that's the thing nowadays. With a billionaire who's one of your friends, you can do that. Well, I don't know if you go to Mars anytime soon, but you can land on Mars and you start digging. That's the first thing you do to get away from the ionizing radiation. And the other thing is you can land on a place where there is a little bit of a magnetic field, and that's good. But if you go to Mercury, it really doesn't have much of a magnetic field either. So, yeah, it all depends on the planet, how fast it's rotating and what it's made out of, determine the magnetic field. But yeah, great question. I could go on with that for hours. And it's really important to life. No magnetic field, no life.
Okay, so I guess the short answer is yes. Some planets don't have magnetic fields, but there's a
small
lot
ones.
Of reasons.
Small ones, yeah. You know, small ones are just small planets aren't very good for anything. To be perfectly honest, they can't. A small planet can't have an atmosphere. A small planet can't have a magnetic field. A small planet can't have life. So
it really is just a lump of rock in space.
Yeah, exactly. They kind of they cool off and die.
Okay, lovely.
Very sad. Very sad.
Okay, more on the topic of sustainability and energy. Marie was wondering, does it take much energy to power a large telescope? So I guess that depends, but maybe you could give us a bit more of a meaty answer there.
Yeah, I guess it depends on the kind of telescope that you're looking at. You know, LOFAR doesn't need an awful lot of power to run the telescope. It kind of just sits there. The data comes in, and it's the computers and that use a bit of energy. It's not too bad. If you go to the really big optical telescopes, they need to be moved around, and that takes power to do that. But again, it's you know, it's probably the equivalent of an articulated truck kind of energy that's required. It's not huge amounts of energy like a data center. So, you know, the energy requirements aren't appreciable for moving them. It's more the data
side of things.
that has the larger carbon footprint.
So a telescope, whether it's radio or optical, a telescope on Earth is basically just looking. So that doesn't take much energy to run it. You're saying it's more storing and analyzing all the information coming in is where the energy sinks.
Yeah, that's much more appreciable.
Okay, great. And we actually have some questions. So based on what we've been chatting about, for all of you to get some thoughts from all of you, and which we'll then go on and discuss with Peter. So we've got a Mentimeter slide. The link will be shared in the chat now, but you should also be able to see it here on your screen. Let me just get it up there. So if you just go to menti.com and pop in the link or the code at the top of the screen, we want to know, what do you think is the most pressing issue for space exploration? Not just space exploration, but also like studying space and astronomy and astrophysics and all these things. Well, what's the most pressing issue? What do you think is one of the most important things that we could do? So there's the link there if you want to, just a much easier way, just to click that link, and then you can type in your response. So it should work on a phone or on the device you're currently using. Okay, interesting. So yeah, the different responses will pop up here, but you can put in a few different if you have many thoughts on the matter. Great. Okay. Peter, we'll have a quick look, seeing what everyone else says, and then
there's
maybe
some questions. There's some questions coming in there already. Maybe I'll pick out one there.
Yeah, go for it.
Yeah, so, just there's what's the biggest challenge in space sustainability facing us right now? And I guess there's another related question there. What would you qualify as the greatest sustainability challenge for space? What do we need to change?
Yeah.
I think there are similar kind of questions. And first of all, what is the definition of space is there are many different definitions. There's just getting 100 kilometers off the planet and putting a satellite, in low Earth orbit. That's getting to space. There's getting to the International Space Station, which is 400 kilometers up. That's nowhere in space. That's where astronauts go. It's just nowhere. You get out to the moon, you're talking about hundreds of thousands of kilometers. You get to the sun, it's, one astronomical unit, which is 150 million kilometers. And then you get so space is enormous. But in order to get any hardware out of our planet, we've got to go through our atmosphere. And to do that, we do it with rockets nowadays. And I guess that's what the biggest challenge is, I think, is around sustainability, is how do we get those rockets not to pollute the atmosphere as they go through it? Now, the other thing is that the rocket boosters themselves, how can you reuse them rather than, producing aluminium, producing all the materials that are required to produce them. And maybe I'll just say something about rockets themselves. There's liquid fuel and there's solid fuel booster rockets that get things up into space. You can burn liquid hydrogen, liquid oxygen. They're nice things to burn, but you will get vapor trails. You get H2O coming out of them. So that's not too bad, but it does have it can have a cooling or a warming effect depending on where it is. You can get carbon dioxide as well from some fuels, but you can have dirtier fuels as well that will produce, say, soot, small particulate matter. And the soot can either be black if it's kind of carbon based, or you can have other kinds of exhausts that are aluminium based. The aluminium based ones can be white or shiny, so solar radiation coming in or solar light coming in will be reflected by them, but then the dark ones can be absorbed. So one of them can have a cooling effect and one of them can have a warming effect on the Earth's atmosphere. At the moment, we have about 100 launches per year, rocket launches per year. So the total contribution isn't large. I mean, if you think about it, airplanes, there's about 100,000 a day, I think, aircraft flights. So that contribution is enormous by comparison. What is different, though, is that rocket flights go up into the stratosphere, which is the upper layers of our atmosphere. And once you're up there, it's very thin, it's very sensitive to extra water vapor, extra carbon dioxide, or more noxious kind of, I guess, pollutants. And we don't understand what's going on with those. So in the future, I think we have to be very careful about what impact we have on the upper layers of the atmosphere. And, I've mentioned like soot and water and CO2 and so on. If you've got a cloud up in the stratosphere or up high, what does it do? Well, the first thing is solar radiation bounces off it, so the Earth becomes more reflective. So there's a cooling effect there, but also a cloud will keep radiation in. So there's a lot of complex chemistry and modeling that needs to be done to understand that. But we can't just willy-nilly do it, and that's what's happening at the moment. That that there is no real consideration given to that. Now, some of the private companies are trying to be more sustainable. Some of the US based commercial spaceflight companies are concerned about this and are trying to work on it. And European Space Agency and NASA are also working on it. But it is our major challenge for sustainable space is not to pollute our atmosphere as we go through it.
Yeah. So, and that's a theme that you can see coming through there very strong with everybody else's opinions as well, that some of the pressing issues for space exploration are climate change, and people seem to be coming at that from different angles, whether it's to protect our Earth or to try and find a new Earth, and also money and the fact that the elite few seem to be the ones who can afford going to space.
Yeah, and that's it's an important point about finding other planets, and it's just not going to happen.
Yeah, it's a very long-term potential solution.
Like the nearest star to us outside our sun is Proxima Centauri, which is 4.2 light years. You've got to be going at, the speed of light for 4.2 years to get there. So if you're going like 10 times less than the speed of light, it's going to take you 40 years to get there. And we can't even do that. So there's no way we can get anywhere within a human lifetime at the moment with current propulsion systems. So finding other planets, we only have this planet. That's it. There is no other planet other than our planet now for the next few hundred years, unless we invent wormholes, which I don't see happening anytime soon.
Right.
So this is it.
So realistically, finding Earth 2.0, not very feasible. Let's focus on trying to fix and protect what we do have.
Maybe 1,000 years we might be able to, but it's certainly not in my grandchildren's or our grandchildren's life time frame. But there was a mention there that, like, going to space also, there's huge benefits to going to space. Space tourism is brand new, okay? And it's a tiny, tiny, tiny fraction of why we go to space. And it is the billionaires who are doing it. So what, who cares? It really doesn't affect what the rest of us are doing with space. The rest of us are, we're going up to do Earth observation. So we're going to put a camera up there and we're going to look down. We're going to see what our forests are doing. We're going to look at our oceans to look at ocean circulation patterns. We're going to look at pollution in our atmosphere. So that's a huge benefit. So the carbon footprint of sending something up there is worth it for the kind of science that we're going to learn, in my opinion, about our planet, about climate or weather patterns. There's also things like GPS systems or navigation systems as well. I think that's a worthwhile thing to do, to put up many spacecraft up there that are going to help us, get trucks around more effectively. If we cut down on the amount of kilometers that trucks are going around on with accurate GPS, we can do that. We can optimize their routes to try and ensure that we're not wasting money going around in circles trying to get places. Similar with boats. If you want to take ships and move them across the ocean, we want to do it in a way that isn't circuitous. We want to get them directly there, and GPS helps us with that. So to me, that's another thing that, that's a benefit to us for the carbon that it costs to go up there. Excuse me. I'm a scientist, so what I care about is, I care about all of these issues, but I care about trying to understand how, in my case, the sun works, or other planets work, and my colleagues care about stars and galaxies and so on. That's human knowledge, and I think human knowledge is what's the information generating. It improves human understanding of the world and the universe around us. And to me, then, that knowledge is also very important for us. And we're chipping away at our understanding, and that'll help us maybe in 100 years' time. And we're adding to human knowledge. And I think that is also a worthwhile use.
Yeah.
I'm not a great fan of billionaires going to space. I'm worried about it becoming low cost. I'd be worried about all of, people going, like the way we in Ireland go to the Canary Islands willy-nilly, at every school break. I don't want to see us willy-nilly going to space. I think we can't do that without a lot of thought about its consequences for the planet.
Okay, so actually that leads us on to, we have another question here, which some people have already started to answer, which is great. And is space exploration worth the financial cost? So Peter mentioned about how much it costs, and that some people can afford to do this with private enterprises. Obviously, for a lot of people, it's government organizations or multi-government organizations that do it, like ESA or NASA or something like that. So it costs a lot of money to send people or any even satellites into space. Now, as Peter mentioned, we have a lot of benefits from these things like GPS positioning satellites, which obviously, it helps you find your directions to your friend's house on your phone, but it also does a lot more huge, important things like deliveries for globally that we have become accustomed to, and that if they just stopped working all of a sudden or fell out of the sky, you'd notice it more than you would expect. So they kind of impact our lives in lots of ways. We've become so familiar and used to them, and even just the internet and connectivity and things like that. So, okay. So, Peter, what do you think?
Yeah, I'm afraid I'm a scientist and I can't help being a scientist, but there's a beautiful picture of the aurora borealis there on the top left of our screen, and this is actually what I work on. Those green flames that you see up on the top left, well, they're not flames, but me and my research group, we look at solar flares, and actually there was a big solar flare today. And it probably is going to produce the aurora borealis over the coming days. So maybe tomorrow night, if you're in a dark part of Ireland, or if you're in a city and you get out of that city and look north towards the horizon, you might see a faint shimmering. When was it? Maybe 5 or 6 years ago, I saw it from Dollymount Strand one night in Dublin. I live near Dollymount, and I went running down at about 11 o'clock at night, and I saw it. There's photographs from Wexford of the aurora around that time as well.
Wow.
And
even as far south as Wexford.
Yeah, and you wouldn't expect to see it, but if you do go out, you might see it. So if you live up north, if you're along the north coast of Ireland, or if you're in Donegal, definitely go and have a look at.
I should have known putting a picture of the aurora would get Peter talking about the sun.
Yeah, but it's also it's interesting in terms of if you're on an airplane flying from Ireland to Greenland, you can see the aurora sometimes as well. But I never like seeing the aurora when I'm on an airplane. I'm always like, yeah, it's gorgeous, but hold on a second. That's ionizing radiation quite close to my airplane. I don't like this. And if you're on the International Space Station, you do go into a shielded area of it where there's more equipment and you can get away from some of this. But over the next 5 years now, solar activity will pick up and we'll get more and more flares and more chances to see the aurora. And actually, I saw one of the questions there: where is a good place, or where's the best place in Ireland to view space?
Charlie was wondering.
Oh, I don't know where the best place in Ireland is.
Well, we do have 2 dark sky parks in Ireland.
We do. There's the Mayo Dark Sky Park. There's actually one in Fermanagh as well, and then there's one in Kerry as well. I mean, they're areas that. Yeah, they're great. But listen, anywhere in the Midlands, away from city lights, if you go out, you should see the Milky Way. For those of us who are in Cork or Dublin or Galway or Belfast, we just can't see the Milky Way. It drives me crazy. But there's a sustainability thing here. And was it Airtricity? No, it wasn't Airtricity. Was it ESB? One of the electricity companies in Ireland recently had a campaign with Chris Hadfield in it. And they were showing, looking down in Ireland from a spacecraft with all these lights on. And I'm looking at it going, does nobody understand this? That we're sending all the light upwards. That's not where the light should be going. If we were doing things right, you wouldn't see Ireland from space. We actually should have a campaign to ensure that Ireland can't be seen from space. And I think that'd be an amazingly simple thing to do. And all that it takes is, instead of having your light bulbs like this sending light everywhere, you put a cap on top of them and you direct the light downwards. That's one thing that you do. So street lighting, just retrofit all the street lighting so that the light is pointed downwards. The other thing is, don't have big bright blue ones, which just the bright blue stuff scatters all over the place and it lights up the air and it reflects off tarmac. Make it more warm, red, yellow kind of color. It's called a warmer color temperature. So get the wavelength right of your LED lights, and make sure it is all not precious sodium lights. Retrofit them with LEDs that are warmer LEDs. And if you do all of that and don't have them too bright, that's another important thing. If you're too bright, then it reflects off and goes up. Then Ireland can't be seen from space. And then maybe our electricity companies can go and boast about how energy efficient we are. They say that you could save about 1/3 of our total costs on lighting if we just changed our fittings and our light bulbs and got that right. And in fact, I suspect it's higher than that. Here ends my rant on lighting.
So that would be beneficial from all aspects. So we'd be able to view the night sky much better, which is just lovely and wonderful. Who doesn't like looking at the stars? But it would save a lot of energy costs because, as you said, you're not wasting all this energy just beaming it out into space unnecessarily.
Yeah, in in Dunsink, we actually have, we're in an area where we have the old landfill beside us. There's green fields around us, and then there's Phoenix Park. And if you look at a map, we're really, really dark. And we've put into the local area plan to the county council, we've suggested that any development in the area, that they will take into account that it is kind of, it's in the city, you know, we're inside the M50. Well, it's just outside the city, but we're inside the M50. But that any development will go that goes on will take it into account, and lighting will be an important aspect of that, so that we don't ruin the night sky and we save money. You know, ultimately that you know,
it's a win-win.
And it's good for nature. You know, the other thing is, you know, if it's like foraging routes, bat or badger trails for foraging, you know, all of that kind of stuff is important, and lighting can affect animal behavior as well. And that's, you know, these are important issues.
Perfect. Okay, so yeah, so actually, let's go to another question for everybody. And we have some questions coming as well. So I'm going to pop another question up about whether or not we think space is worth not just the financial cost, but the carbon cost of it. But while everyone is popping in those answers, Julie has a question that maybe you could answer, Peter. And Julie's wondering, with such easy access, would we run into issues of space traffic?
Yeah. There's a couple of things there that we haven't really addressed, and I'll come back to the traffic in a second. The cost is an interesting one. The amount of money that we spend on, say the European Space Agency. Ireland has been a member of the European Space Agency since 1975. We're one of the earliest, you know, members of the European Space Agency, and NASA's been around for a long time as well. But the cost is actually, as a fraction of the total budget that we all spend, is tiny. It's only 1%. You know, it's actually a small amount of money. The industry is worth, you know, trillions, but as a fraction of our total money, and it's way below our defence spending. Well, not Ireland's defence spending, but what other countries spend on defence, which is a really good thing. So space, we don't spend an enormous amount of our budget on it, even though there are costly things when you hear €1 billion. Now, I have worked for the European Space Agency, as was talked about at the beginning, and I was responsible for reviewing spacecraft, or picking spacecraft. No, recommending which spacecraft, get my words right here, recommending different space missions that we were using. And at the very beginning, the director said to us, a group of scientists said, be really careful with your choice of science here. Make sure that Europeans get the best science that we possibly can get. Remember that this mission is the price of a hospital. That's how important it is. Think about these missions in terms of units of hospitals. And it's not an either or between a hospital and this, but that night in the hotel, as I was reading the proposals, I was like, you better do your job right here. So, you know, we're very conscientious about how we spend that. We want to win Nobel Prizes, we want our colleagues to win Nobel Prizes because of how great the science is. You know, actually, the motivation for science is not Nobel Prizes. I shouldn't have said it that way. We're motivated by discoveries. You know, that's the big thing. But the big discoveries end up with Nobel Prizes. And it was great to see this week, actually, that the Nobel Prize in physics and actually in chemistry both were related to climate. The Nobel Prize for physics was, actually, I teach it in my 4th year course on planetary science, but you know, you've got a layer of atmosphere here, light comes in from the sun, a third of it gets reflected, and then as it goes through the atmosphere, some of it gets absorbed, and then when it gets to the surface, it heats up the surface, and the surface re-emits in infrared. And it was that whole balance and how CO2 plays a role that won the Nobel Prize. So, you know, and this was a discovery from the 1960s. And it's something that, you know, we now teach in classes. But great to see that the importance of that climate research being recognized by the Nobel Committee.
Yeah.
I'm sorry.
So on a similar topic, So about the carbon footprint and the carbon cost of space exploration and space travel, obviously it's huge, and there are ways that we are mitigating and reducing that, like Niall and Niamh were talking about, and Peter, you mentioned as well different kinds of rockets and reusable rockets that some companies have come up with, which makes a big difference. But Dee has a question, and what if the rocket fuel was from trapped cow emissions?
What's that? Methane?
Methane? Yeah, I think so.
Yeah. Oh, yeah. Sorry, it says it there. Yeah, methane. So that's a really interesting one. Herds in Ireland are kept in fields, and it's really hard to capture it. So in Ireland, that ain't an easy one. But in other countries, cattle can be kept indoors for long periods of time, and you can capture the methane from them. If you burn methane, you get water and CO2 from it. Again, they form clouds, and clouds can have cooling and warming effects. So there can be a carbon effect on it. But yeah, interesting.
Would the methane that's being produced by cows have a carbon footprint anyway? And are we sort of just using it, like for one footprint, we're getting two things out of it? Or does it make it worse if we burn it up?
Yeah, I'm not entirely sure.
Okay, maybe this is more a question for an agricultural.
I mean, what the methane does is, methane's a funny molecule that it doesn't see solar radiation, so the solar radiation passes by it, but it loves infrared radiation that comes off the surface of the Earth. So it starts spinning like crazy and warming up as soon as infrared light hits it from the ground. So that's why it's a greenhouse gas like CO2.
Okay, so Sarah, one of our colleagues in the Rediscovery Centre is also wondering, is there other alternative fuels for rockets, like hydrogen or something like that?
Yeah, well, I mean, the liquid hydrogen and liquid oxygen are good alternatives. But, as I mentioned, they still will produce a vapor trail of H2O, and that still produces a cloud. If what clouds do, and it depends on where the cloud is formed, but if you have a cloudy atmosphere, so imagine if I just took lots of water droplets and sprayed them up into the Earth's atmosphere. And if you look from above, it's white. And the reason it's white is it's reflecting light from the sun. So that means that the Earth will cool. That's one thing that they have. But if I have other clouds that are, say, lower, well, altitude has a big effect. But the other thing is that then infrared light can be reflected, and they can have a blanketing effect, a thermal blanket effect. So even though they're not pollutants, so a liquid hydrogen or liquid oxygen aren't pollutants per se, they could have cooling effects or heating effects on our atmosphere. So you got to be careful about that. But I think as it is they are probably the best fuels that we can look at, because the other ones that are producing soot, that are producing aluminium compounds, that are producing, there's one particularly dirty one that it's a very toxic fuel. What's it called? HCN or something like that. That's not particularly nice. And actually, some spacecraft that have been launched, and this is an interesting ethical problem, is that some spacecraft will have a battery on board, or satellites will have a battery on board, and that battery can have plutonium in it. Because if you want to go to Jupiter or Saturn or the edge of the solar system and sit there for a long time, you can have your solar panels, but the further away you go from the sun, the smaller the sun becomes, and they just become very ineffective. So if you're out there, having your own battery that's a nuclear battery is really good. But what happens if you launch it from Florida and it blows up and you put plutonium all over the place? So when Cassini was launched, which is a spacecraft, oh God, it must be 20 years ago at this point, there was huge opposition to it because of the danger of plutonium batteries blowing up. And then imagine plutonium being in an atmosphere or dispersed. So, and Niall Smith earlier talked about rocket launches going out across the sea. Florida's good because you can fire things off to the east. But so what? You drop plutonium into the sea or into the atmosphere, you just do not want to do that.
No, of course. So Peter, I'm sure you can see our results there. Most people are not convinced that space exploration is worth the carbon footprint. So maybe people feel that means we need to improve our car and reduce the carbon footprint and still continue doing space exploration. Hopefully nobody is suggesting that we just fully stop space exploration. But Sarah was wondering, are there any rovers or rockets ever made from recycled materials?
No. I don't believe there has ever been one made from recycled materials. I mean, it's funny if you look at the space shuttle. Now that's going back. When was the space shuttle first launched? Was it 1980 or something like that? Maybe even before that. But it was a reusable vehicle, and there was several space shuttles that were reusable vehicles. But you had your solid rocket boosters, your liquid, your booster, and then and they would drop down into the ocean and they would be retrieved. So they were constantly being reused again. So that was a very sustainable way of doing it in the 80s. Now, I think they were doing it for financial reasons, but it doesn't matter. And then the main space shuttle itself was the idea was that it would be constantly reusable. So they were instances of things that were constantly being used over and over again. And SpaceX at the moment as well, their launchers. I mean, I almost thought it was being made up the first time I saw it. Rockets go up and off they go into space, but this thing came back down again, and you could see it coming down and landing. And the physics and engineering that's required to stop that thing from pivoting around but actually land was incredible. But it allows that to be reused again, or allows the rocket to be reused. Sugar, I usually have a model of a rocket in my office, but it's downstairs.
And obviously reusing that greatly reduces the cost, but also the environmental impact, because you're reusing the whole thing. Obviously you still have rocket fuel. It's still not zero, but it does reduce it a lot.
Yeah, absolutely.
Cool. So actually on that, so you mentioned SpaceX, which is, as I'm sure a lot of people are aware, run by a billionaire. And that kind of leads us to a lot of nowadays with space tourism coming up now and everything, a lot of billionaires are just kind of taking themselves and their friends to space. So we do have another question for you guys. Who should get to go to space? Like, how do we feel about this? Because the other options, astronauts who go to space, are usually in organizations, either multi-governmental or governmental organizations like NASA or ESA, which is the European Space Agency, which Ireland is a member of. And they are experts. They are scientists, engineers, who get highly trained to space and do research when they're in space and do things that help us understand everything a lot more and see how plants would grow in microgravity and how different things would interact. And they work when they're in space. They're not just going for the fun. So, okay. So, but then there are now as well some civilians who have gone to space. Just this week, I believe, Peter, some people were launched from Russia, a Russian actress and a film director, to make the first film in space. And they are civilians. They're not actually astronauts, but they were sent up to space. And this could be really good from a cultural perspective. The crossover between science and the arts, it's really great. But is it worth sending somebody to space when it costs so much to send an individual? So what are your thoughts on this, Peter? You can see some of the answers there.
I'd almost rephrase the question: should we even send people to space? I don't know. Are you better off? I think. Well, send robots, send probes. Listen, I'm a scientist who uses, and my community, we use satellites that have telescopes on board them. We have spectrometers. We have all kinds of scientific instruments on them. We have rovers that land on comets and drill into them to find out what they're made of. We have other, landers and orbiters and so on that go out to Mars and Venus. And Bepi Colombo did a lovely loop past European Space Agency's satellite of Mercury last week and got beautiful pictures. They can tell us so much about these planets. But that said, we as a species, 500 years ago, we couldn't get across the ocean. Like in the 1400s, we couldn't navigate, and we kept on trying, and now we take it for granted that we can. So I do feel that it's a costly effort to put humans into near space. But we learn a lot more scientifically from probes and so on. The billionaires going to space, you're not going to stop them. I think that's a problem of our society and the way we allow small numbers of people accumulate vast wealths. There's something wrong with our tax system. There's something wrong with the way society allows people get so rich. But that's an issue well beyond space. That's one for governments and people to think about how we run our societies. I think it's very unfair. I think space should be for the benefit of all. And I think it should be something that brings nations together. And in fact, that is one thing that is very true about space. If you look, even during the Cold War, Russia or the USSR at the time and the United States were still cooperating on space. It's a great leveler. And within Europe, we all cooperate together. Even, the European Space Agency is not the European Commission. The United Kingdom are still part of the European Space Agency. Canada are part of the United Space Agency, or the European Space Agency. And then, most missions nowadays, like the James Webb Space Telescope, which will be launched at the end of this year, is NASA and Europe working together for public good to understand science. So I think space is a great way of human cooperation in around something that isn't financially competitive.
Definitely. And even like the International Space Station, it really is international.
Yeah. And always has been. It's funny, very different attitudes as well. It's almost a psychology and cultural experiment. And I think you can learn a lot about how people interact with one another from life on the ISS.
Yeah. So you see some of the suggestions coming in here. Some, as you said, Peter, some people saying things like robots and artificial intelligence. The experts should be the ones sent to space, scientists and researchers. But then also we have got some strong suggestions for David Attenborough, Morgan Freeman, and Buzz Lightyear to be sent to space. So maybe
David Attenborough. If there's the first person,
David Attenborough wouldn't agree with that.
Well, David Attenborough, if we had David Attenborough going to another planet, I think we would all be very happy for him to go around and be the first person to describe what he sees on the surface of Mars. And he'd probably be happy to go as well, I'm sure.
Even with the potential environmental impact it would have on our own planet.
Yeah. Maybe not.
He would be wonderful at explaining everything we're seeing. Brilliant. So yeah, we'll take that off the screen now, but there's some other things that are great to think about with all this, and it's great getting everybody's input and all these opinions coming in, which is great. But talking about all these things, and something that akin to what Niall mentioned earlier, this sort of web of satellites around the Earth that really help with communications and do help level the playing field globally from, here in Ireland, we've got great connectivity. We take a lot of these things for granted. In other parts of the world, maybe not so much. So there's, all these different satellites and some result in space junk, which can be a problem. But also then there's new ones like Starlink. Peter, can you maybe tell us a little bit what's Starlink?
And actually you asked a question earlier about space traffic that, I went off and talked about the wrong topic after you asked that question. I mean, there are no rules and regulations around what you can launch up into space at the moment. The Starlink is a network of satellites that's been put up by SpaceX. It's been used to provide the internet across the planet. It's very expensive internet in reality, but these Starlink satellites cause trails, bright trails across the night sky. So for optical astronomers, it's a real problem. When they're trying to look at a very faint object with a big telescope and there's streaks going across it, it's going to ruin their data. I don't really want my night sky constantly zipping past with little bright lights. I don't want to see a situation where we've got, McDonald's, Coca-Cola signs in our above our heads, and all stuff that goes up there takes a long time to deorbit, and in order to get back down, it takes years. So there is a problem with space junk building up there, and so as you fly through, you could get hit by something, and that damages. You can lose a 100 million euro spacecraft, or somebody could die. So there is a problem about building up space junk out there, and there's lots of programs that are tracking all the space junk, so we know where it all is. So yeah, I mean, there is traffic and junk in space, and it is a concern, but there's very little regulation around it.
Yeah. So actually, we've got another question for the audience there. Is something like Starlink net positive or net negative? So there's benefits to it. As Peter said, though, it kind of disturbs the night sky and it's not very nice. And there's a load of Starlink together, right? They kind of go across in streaks of groups.
Yeah, when you see them launched, there'll be multiple ones, like a string of pearls as they go across the night sky, and they all light up. So, yeah.
So Rose actually has a comment. We only have a couple of minutes left, so we're just going to fly through another few things to get some conversation points started. But Rose got a comment. Going back to space junk, a Harpoon has been successfully tested in space in February 2019. The Harpoon was developed by Airbus UK, collaborating with satellite technology and Surrey University. So am I correct in thinking that would be a Harpoon reel in and clean up some of this space junk?
Yeah, I don't know anything about that. I haven't heard about it.
Okay, so maybe that would be something useful to try and clean it all up. But then I guess it poses the question, what do we actually do with it?
Yeah.
Okay, great. So yeah, people are definitely divided on this whole Starlink issue. So we'll.
What are the results there? I can't see it.
So we've got about 25% saying it's positive, it's bringing global connectivity, and 75% saying negative, it's ruining the night sky for all and not globally agreed. So it's quite nuanced, I suppose. It's not always clear to say it's just good or bad, because there's pros and cons, but overall people seem to disagree. But I'd say a lot of people maybe have an issue with the fact that one person just decided to do this and went ahead. It wasn't a universal global agreement. Yeah. Great. We're just going to take that off the screen now because Ali has popped back up here because we are running out of time.
What I always do, I just pop in and I'm a bit of a party pooper at the end because I'm going to shut things down, unfortunately. Guys, that was unbelievably interesting. I have to say, Peter, one thing that you said that particularly piqued my interest was the effect of light pollution on animal behavior. Funnily enough, it was the topic of my master's thesis, was light pollution affecting hermit crab behavior. So that very much piqued my interest. Just a little bit.
Very good. My wife is a bat biologist, and so she's very.
Funnily enough, taught by your wife. At some point. Yes, I was wondering.
Okay, yeah.
Was I going to drop the elephant in the room, or was someone else going to do it?
Okay, great. Okay, well, yeah.
I think this is a good example of we have such a small connected world. We do need to protect it.
Yeah, well, yeah.
And it's one thing that's obviously very tricky about, and one of the main points I think of to sum up this kind of session here was, in some ways, the most sustainable thing we can do for space exploration is to stop space exploration altogether, almost, in some ways. When you look at the way that it is damaging ecosystems and damaging the universe, sometimes the most sustainable thing to do is to stop, but obviously no one's really too keen on doing that either at the same time. So it's very controversial and a very
there's a carbon footprint to doing, even to do environmental science, there's a carbon footprint to it. So we have to work out what we learn from it and how it can be of benefit to us to deal with all of these issues afterwards. And it's the same with space travel as well, and space exploration.
Absolutely. Well, Peter and Anya, thank you both very, very much for joining us. We are going to have to say goodbye there. We're going to take a super, super quick break, and when we come back, we're going to be joined by Dr. Peter Martinez, who is the Executive Director of the Secure World Foundation. So we'll take a 1-minute break, and we will pop back in for that in just 1 minute's time. Again, thank you both very much for joining us today. It was very, very fascinating and definitely food for thought for going forward. Thank you both very much for joining.
Thanks so much for having us.
Thank you, everyone. Bye.
All right, we'll see everyone back here in 1 minute. Set your timer. Put the kettle on. We'll be back. Hello again, everybody, from the quickest break of all time. I'm delighted now that we're going to be joined by Dr. Peter Martinez, who, as I said, is the Executive Director of the Secure World Foundation, which some people may be familiar with, basically concerned with promoting the secure, sustainable and peaceful use of outer space to benefit Earth and all of its people. Dr. Martinez, we're delighted to have you on board. How are things with you today?
Wonderful, thank you. Good afternoon to you. It's early in the morning for me here in Colorado, but pleasure to be with you all today.
Our furthest reach so far today that we're aware of anyway. So thank you very much for taking time out of your busy morning, as it is afternoon for us, to take part. So do you want to tell us very briefly maybe about the Secure World Foundation, and then I'll let you kind of go ahead with what it is you want to talk about, and then I can pop back in at the end to facilitate some questions, if that sounds good to you.
Sure, thank you. So very briefly, Secure World Foundation is a private operating foundation that is based here in the United States, but we have an international footprint, and we work mainly in the area of space sustainability. And by that, I mean how we preserve outer space to keep it useful for all countries, not only of our current generation, but future generations. And I have a few slides to show that kind of illustrate some of these points. So perhaps if we could bring those up, I will speak to those. Thank you. We heard at the end of the last presentation the concerns about the growing uses of space, and there was a comment made that perhaps we're beginning to mess up outer space, and really maybe the best thing we can do is to stop space activities. And I want to show you why we really don't want to do that, and we want to strike a balance. So if we could go to the next slide, please. When we think about space, when most people in the public think about space, this is perhaps the first thing that comes to mind, is things like the International Space Station, Mars exploration, exploration on the moon, rockets, astronauts, all this kind of stuff, which is very exciting. And we've learned an awful lot about the universe and the solar system that we live in. But the planet that matters most to us is the planet we actually live on. Next slide, please. And so this is a picture of Dublin, and you may not think Ireland is perhaps not one of the world's leading space countries, but just like every other modern country, Ireland makes very, very heavy use of space technology, and hopefully will soon also become one of the actors in outer space, as I believe from a mission that's being planned and built in Ireland. But let me just show you some of the many ways that we use space technology. Next slide. So a very common use of space technology is what we call Earth observation. So those weather forecasts, the weather maps that you see on TV, things like monitoring crop production, disaster management, fires, all those kinds of things rely on Earth observation satellites. Next slide. Another very common area of space technology application is in communications. We heard a lot in the previous talk about broadband constellations of satellites that will bring the internet to every corner of the globe where we don't have fiber or other forms of terrestrial communications infrastructure. And this can help in terms of education, health and safety, and all such issues. Next slide. Another area that many people are aware of that space technology is useful is in positioning and navigation. Many of us use Google Maps and navigation to get to places that we're not familiar with, and that is satellite-aided navigation is extremely useful, but also those satellites provide timing signals that enable things like cell phone networks, the internet, banking, and so on. So those are all ways in which we're critically reliant on space. Next slide. And so we may not realize it, but we are living in bathed in space-derived information and data that we all personally rely on every day of our lives. And if we were to lose those capabilities, then we would find that very disruptive for the way that our modern societies work. And so, next slide. we see in this slide, which shows a street scene from Wall Street in New York City, but it could just as well be any other major modern city. And you can see the many ways that space technology is being used. For example, the lady in the foreground on the bottom right is looking at her cell phone to guide her to her next business meeting. The gentleman in the bottom left corner is having a conversation on his cell phone, which relies on timing signals for cell phone networks. You see street lights in the background and traffic lights also indicated in circles. That's because many of those systems also rely on timing signals derived from space systems. And then finally, you see the Wall Street sign with a circle around it, because also we find that satellites make very important contributions to financial markets, or the operation of financial markets. And so those are some of the ways that we all rely on space technology, and it's part of the plumbing of modern life. Next slide. But it's not only the most developed nations that make use of space technology, it's emerging or developing countries as well, many emerging space nations. And this is a street scene from somewhere in Asia, India, if my memory serves me correctly. And you see all the many satellite dishes that are being used there. I could show similar scenes from Africa, from parts of South America, where, again, countries that you would not think of as space nations, but that are critically reliant on space technology. Next slide. So all these satellites are put into space in a variety of orbits that are chosen depending on the kind of service that will be used. Many of the satellites that are going up now, you may have heard about the Starlink constellation. I think that was part of the discussion in the previous talk. That's what we call low Earth orbit, and those are orbits that are under 1,000 kilometers. Then we have medium Earth orbit, and those are orbits out around 10,000 kilometers. Those are where you would find, for example, the navigation systems like GPS or GLONASS or Galileo. And then the geostationary orbit, that's about 36,000 kilometers high, and those are the satellites that provide broadcasting services. And that orbit is very special because it takes 24 hours for a satellite to go once around the Earth at that orbit. And if you place a satellite there, it goes around the Earth just as rapidly as the Earth turns on its axis. And so therefore the satellite appears to be fixed in the sky, and that's why you can fix a TV dish to the side of your house and not have to move it. Next slide. Now these orbits are getting very, very crowded. In the beginning of the space age in 1957, there was just, Sputnik went up and we just had one satellite. Next slide. A few years later, we started to see, next slide please. We started to see by 1960, we had a few satellites in orbit. Next slide. By 1970, you could see that the, the Earth's orbits were beginning to become more and more crowded. On the left-hand side, you see the low Earth orbit, and over on the right-hand side, a bit further away, you can see the geostationary orbit also starting to become populated. Next slide. By 1980s, you could see how this was becoming more and more crowded. Next, 1990s, 2000s, next slide, and then 2010. Final slide in the sequence, and you can see how the space environment is incredibly congested. Now, many satellites have been put up, and they have a finite lifetime in space, which is normally governed by the amount of fuel that they have on board to operate. And so when that fuel runs out, the satellite basically becomes space junk. And so let me give you a terrestrial analogy. If you think of orbits as the kind of the highways in the sky, and to bring that analogy down to Earth, imagine if you were to have a car and you were to drive it on the freeway until you ran out of petrol, or until it broke. And at that point, when you ran out of petrol, you would just leave it right there in the middle of the freeway and abandon it. That's exactly what's happening in outer space. We have tens of thousands of objects that are up there that are not providing any useful function and that are a collision hazard to other users of space. And so those are really concerns to all users of space, how we regulate this use. Next slide. And so the space arena has changed a lot in the last 60 years. This is what it looked like in 1966, which it was in the early days of the space age, and you only had the United States and the Soviet Union as the two dominant space powers, and a few other countries that were space actors. Fast forward 60 years, next slide, you see that this map is now showing many, many more countries as active users of space. And this map is a few years old. If I was to show it for 2021, there would be even more of the map colored in orange. Next slide. So we have a more global space arena. That means that when countries talk about the ways that we utilize space, the conversations are becoming much more complex and dynamic. In the early days of the space age, you had a few countries in the space club that were more or less on par with each other in terms of their diplomatic and technical capabilities. As I said, the US and the Soviet Union were the leaders, with a few other countries that were involved. Next slide. Fast forward to now. This is, by the way, it's the same committee. The previous slide that I showed you was the United Nations Committee on the Peaceful Uses of Outer Space that started with 24 countries. There are now 94 countries in the committee, and it makes governance of space quite a challenging issue. Next slide. Also, we see that the composition of the space actors is changing. In the early days of the space age, space activities were dominated by the military actors in the Soviet Union and the United States. Gradually, we started to see more civilian actors coming on board. So on this slide, you see in the red and orange, the military and civilian actors from Soviet Union, dark blue and light blue military and civilian actors from the United States. Then the yellow band shows other countries becoming space actors, and you can see that throughout the 80s and 90s, more and more countries became spacefaring. But what I want to draw your attention to is the green band, which is private companies that have become the dominant space actors. And so most of the satellites going into space are from the private sector these days. Next slide. And we're also seeing a whole bunch of new space activities, things that were never imagined before, like servicing of spacecraft in space, refueling them. Remember I said to you we have a problem about spacecraft running out of fuel. Well, if we can refuel them in space, we can have longer operating lives of spacecraft. Next slide. Also, we are seeing lots of discussion around the use of resources on the moon and other celestial bodies, such as the asteroids or other planets. And indeed, if humans ever become a permanent multi-world species, we will have to learn to live off of the resources on the moon, the asteroids, and other planets. And so there are lots of legal questions around this. Next slide. Now, another development that's happened that's become a game changer is all these very large constellations of satellites with, thousands or tens of thousands of satellites in just one system. And there isn't only one of these, there are several of these being proposed that could see us having as many as 10,000 additional satellites launched over the coming decade. Now, I don't believe that all of these business plans will come to fruition, but even if only a fraction of them do, then that will mean that space is going to become even more crowded. Next slide. And so as countries become more reliant on space, they, of course, will rely on space technology for their national security and defense. And that means that space systems then could potentially become the targets of attack in situations of military confrontation. And if that was to happen, you could have huge amounts of space debris generated in orbit that would pose a huge threat to all other users of space. And so we are very concerned about the possible proliferation of space or anti-satellite weapons, and definitely the use of that would be bad for everybody. Next slide. And so I've mentioned all this debris that's up there in space, and we will have to start cleaning it up. Because even if we were to stop launching new space systems right now, the amount of debris in space would continue to grow through debris on debris collisions between, the various defunct satellites and debris objects. And so we need to clean up space. And there are a number of space agencies and companies that are developing technologies to clean up outer space. So there are technical solutions to this. Next slide. There are also solutions in terms of how we behave in outer space. We're all familiar with certain norms of behavior on Earth, things that people do not because the law requires them to do, but because it's just considered to be normal, decent, civilized forms of behavior. And so that too can be a way that people can operate their systems in space in a way that takes into account that the fact that there are other users of space and there will be other generations following us that will want to use space. Next slide. And then the final way of addressing this is through enacting laws. Because space activities are very international in nature, they are regulated both by the country of origin, the country that has jurisdiction over a space system, and in international law, the states are responsible for regulating their own space activities. And of course, next slide, we also have international agreements such as treaties, and this document with all the signatures is something that was recently negotiated by the United Nations with these kinds of norms of behavior that I was talking about that countries can voluntarily adopt. So I'll stop there and we can use the remaining time to take questions. Thanks very much.
Thank you very much for that, Dr. Martinez. A very great insight into, kind of the more social issues, I suppose, when it comes to space exploration. Obviously, throughout the Earth's history, there have been a lot of conflicts over territories. Can a country claim territory on the moon, let's say? Because lots of different countries have been to the moon at different stages. So what's to stop a country claiming territory on the moon itself, for example?
Great, thanks. That question's always a great conversation starter in these discussions. So, in terms of the international treaties, no states are allowed to appropriate an orbit in outer space or a territory on the moon. States are allowed to free passage through outer space. They're allowed to access the moon and other celestial bodies. They're allowed to use the resources on the moon for, extracting oxygen, for supporting a mission or whatever, but states are not allowed to appropriate either by claim of sovereignty or by some kind of means of use outer space. And so this is why there have been questions raised about these very large constellations of thousands of satellites that essentially kind of populate an orbit so densely that you might say, well, who else would dare to operate their system in such an orbit? So it does raise these kinds of questions, and it's still very much a hot topic of discussion among space lawyers.
Yeah, of course, because while, a country can't necessarily claim an area, if they pack it so densely, no one else can squeeze their way in. So they've kind of claimed it by default almost. And, when we look at kind of legislation on this, is all of this kind of legislation and the you can't dominate an area in space, is this all governed by the United Nations? Is it kind of an unspoken rule, or what's the kind of the true, I suppose, legislation behind it all?
Yeah. So the Outer Space Treaty, if you like, is the sort of the Magna Carta of space legislation. And so that has been ratified by well over 100 countries. And so the way it works is that there is no international space policeman that will come and give you a ticket if you're doing something bad in space. And so the way that the international treaty is implemented is through national legislation. So the countries that have ratified the Outer Space Treaty then enact national legislation that gives legal teeth to the provisions of the treaty, and it becomes binding on all of the the juristic persons, be they a real natural person or a company operating within that legal jurisdiction. And that is really how these things are implemented. So that approach is applied not only to the provisions of the treaty, which are binding on states, so states are bound to implement the treaty, but also there are many United Nations General Assembly resolutions, guidelines, and so on that are not binding in the way that a treaty is, but that states still voluntarily adopt into their national legislation and therefore make it binding. And indeed, many provisions for space debris are of that nature, in the sense that the Outer Space Treaty doesn't talk about space debris, but there are UN General Assembly resolutions that address the matter, and several countries have adopted some of those principles in their national legislation, which they then take into consideration as part of the licensing process when they authorize a space mission.
So obviously, as you're saying, states are bound by the treaty, and that presumably also is in place for all of these privately owned space exploration organizations that we're seeing coming through. Are they bound by the treaty in the same way because they're obviously operating within a state, or how does that work?
Yeah, good question. So the way it works in international law is that states are liable for the space activities of their nationals. So, for example, if you decide, and you could in principle do this, you could go online, you could order all the components to build a small satellite in your own home. If you had enough money, you could probably find somebody to launch it for you. And if you did that in terms of international law, it would be the state of Ireland that would be responsible for the object internationally. And so that's why states enact national legislation, is so that they can then control the space activities within their own country. So yes, these very large systems that are going up fall under the jurisdiction of whatever state they're registered under, and those states are liable. So when a state, this is a very important point, when a state licenses a space project, that state is accepting international liability for any damages that may be caused from that space activity. In other words, that is ultimately the taxpayers that they are signing up to honor such a liability should it arise in the future.
Yeah, and that actually leads quite nicely into a question that's come in from the chat from Julie, who's asking, how important is it for Ireland to develop a space agency itself? If we had our own space agency, would we have more governance over what happens in our own country, rather than obviously we're part of the European Space Agency? Would we have more jurisdiction and more impact on space travel were we to set up our own space agency, or are we kind of better off sticking with ESA as a whole?
Yeah, that's a very good question, and there's no simple answer to that. I would say that having a poorly funded and a poorly supported space agency in terms of political support, funding, industrial support, etc., is perhaps worse than not having a space agency at all. A space agency is not the only answer, but if a country wishes to set up a space agency, then I would say that a necessary condition for the success of that is that there be strong political support for the agency so that its programs be funded, because there's nothing worse than having an agency that's poorly supported and basically has no traction, and then government could in principle tick the box and say we have a space agency, but it's not doing much. The connection with the European Space Agency, I think, gives Ireland access to amazing space programs and science conducted by ESA, and so I think that is excellent. And having said that, many of the ESA member states also have their own national space programs. ESA, as I'm sure many in the audience knows, operates with what's called a geographic return principle, which means that the investments by Ireland into the European Space Agency ultimately come back to Irish industry, to Irish companies. So there is a return on that investment to the European Space Agency. Also, another very important factor is that I understand that there is an intention to launch Ireland's first national satellite that's actually under an ESA program. This is very exciting, and I would be interested to find out more about developments around a national space policy or national legislation in Ireland, because as I was saying earlier, states are responsible for the space activities of their nationals, and so therefore, this upcoming space mission will have to be licensed. There will have to be continuing supervision of the mission, and so it can provide an impulse for the development of a national space regulatory framework as well.
Yeah, very interesting. And so obviously we're saying, things are happening in Ireland, which is obviously very exciting. We've seen from all of our speakers today that there's a lot of people in Ireland who are involved in space exploration in some way or another. Is every country as involved? We had a question coming in that's asking, has every country in the world ratified the space treaty, or were some very against it from word go, or was everyone very much on board with it?
Yeah, no, the space treaty the outer space treaty has been very widely ratified. It's well over 100 countries. I forget the exact number, but pretty much all of the current spacefaring countries, almost all of them have ratified the treaty. There are more and more countries that are becoming spacefaring. Just a week ago, I saw an announcement of a country on the African continent that is intending to launch its first satellite very soon, within the next year or two. They have not ratified the treaty. And so one would hope that as countries reach that threshold of becoming space actors themselves, that they would consider ratifying the treaty and agreeing to operate in space by those principles.
Okay, yeah, definitely something, I think another question came into the chat there from Charlie, who's asking, is there anything endangering security in space for future generations? And obviously, I suppose the fact that some countries may not ratify the treaty could theoretically endanger security in the future?
Yes. So space sustainability, which is preserving the space environment for current and future users, and space security are kind of two opposite sides of the same coin. And I like to think of it, if you think of the rim of the coin, is then space safety. So anything that endangers safety in space is ultimately not good for commercial actors or military space actors. And so we have to be very careful as countries become more and more reliant on space for their national security and defense, that we have to be very careful that space systems don't become targets in the event of a military conflict, or that conflicts on Earth don't extend into space. Because unlike terrestrial conflicts that are largely geographically confined, the effects of conflict in space actually spread out across a very wide shell of orbits, and ultimately impact all other users of space. So blowing up stuff in space in a military conflict is a really, really bad idea, and the world should avoid this if at all possible.
So what you're saying is Star Wars is literally the last thing we could possibly want to happen.
It's absolutely not, it would deny us of all the things that we take for granted in our daily lives, the benefits of space. And also we would be robbing future generations of these wonderful benefits that we enjoy. So we definitely want to avoid a conflict in space where things are being, destroyed and blown up. And I should also add, even before that, if countries develop systems that they need to test, and the tests involve blowing up stuff in space, even that is a bad thing that should be avoided.
Yeah, as much as it's possible. Dr. McNews, I'm afraid we are going to have to wrap things up here. So thank you very much for joining us today. Like I said, morning for you, afternoon for us. So thank you very much for taking time out of your day to join us. I'm sure there will continue to be a stream of questions coming through the chat even after the event. So we want to encourage people as much as possible to stay connected with the event and stay engaged with the event. So we want people as much as possible to connect with us on social media, continue to ask questions, and if there's some questions we just can't answer, we maybe get in touch with you again in the future to give us a few answers to those, if you wouldn't mind.
Absolutely, be happy to do so. And congratulations on your program and happy World Space Week to everyone.
Thank you very much, Dr. Martinez. It's been absolutely lovely chatting to you. So yeah, on that note, guys, please do stay engaged with us as much as you possibly can on social media. If you've taken any pictures during the event today, if there's any further questions you want to ask, if you did get involved in making rockets and landers, I understand that we did get some submissions already. The event has only happened today, but we did have some amazing examples of rockets sent to us like this one that you can see here. So if you do try anything that we've talked about in today's event, or if you want to know a little bit more, if you want to reach out to any of our speakers, please do stay in touch on social media. All of our handles will be all over the place at the end of the event. We are unfortunately going to have to wrap things up a little bit, so I would like to take this opportunity to thank all of our amazing speakers. Today we learned all about space junk, following our dreams, how space travel can help us understand Earth sustainability issues, appreciating what we have here on planet Earth, rather than maybe looking for another home elsewhere, and how now that there are more and more players coming on board into the whole realm of space exploration, we're going to have to work together rather than separately to achieve any of our goals. I'd like to thank Anna Taylor, Dr. Niamh Shaw, Dr. Niall Smith, Dr. Peter Gallagher, Anya Flood, Dr. Peter Martinez, and of course our friends over at Science Foundation Ireland for making this event happen. Again, thank you all very, very much for joining. Keep in touch with us on social media. Keep an eye on our website because we've got loads more events coming up over the next while as part of our STEM and Sustainability project funded by Science Foundation Ireland, and also just the stuff we got up to all the time. So do keep in touch. Thank you all very, very much for joining, and hopefully we'll see you at the next one. Thanks a million, everybody. Oh.